Hey guys, welcome to my channel. Did you know that China is internationally acclaimed as the infrastructure maniac? This nickname isn't derogatory. It reflects the awe of the international community towards China's infrastructure construction capabilities. China has gained global recognition for its ambitious mega-projects tailored to accommodate its rapidly growing population. From constructing highways capable of serving as airplane runways to dams that dwarf even the legendary Noah's Ark, China has pushed the boundaries of construction to astonishing limits. Today, we embark on a journey through China's gargantuan mega-projects that have reshaped the nation, leaving us all wondering if they were secretly competing with giants from fairy tales. Buckle up for an awe-inspiring ride. Before we delve into these remarkable projects, be sure to subscribe to Machine Eye. Currently, only 5% of our viewers are subscribed. Help us reach a 10% subscription rate. Your support means the world to us. Thank you all so much. Countless world records, countless proud achievements, behind which are countless ordinary workers, achieving extraordinary, almost pathological, limits through sacrifice. In China, there is a popular saying, "To get rich, first build roads." Yes, transportation is not only a prerequisite for economic development but also an important guarantee. Only by enabling the movement of people and goods can prosperity be possible. Cut paths through mountains and build bridges across rivers. China's infrastructure achievements are there for all to see, continuously connecting the country into one. Over the past decade, the operational mileage of high-speed railways has increased from less than 10,000 kilometers to 40,000 kilometers. And the mileage of expressways has increased from 96,000 kilometers to 169,000 kilometers, giving China the world's largest high-speed railway network and expressway network. You might be curious, why is China called the infrastructure maniac? The answer is multifaceted. Firstly, China's vast population and vast land create an urgent need for infrastructure. The technological dividend of engineers and the continuous progress of science and technology have also continuously improved the productivity of infrastructure construction. In addition, China's unique form of government organization helps concentrate efforts to accomplish great things. However, one thing that absolutely cannot be ignored among these factors is the unparalleled spirit of hard work and endurance that the Chinese people possess. Over the years, China has truly lived up to its reputation as an infrastructure maniac. Let's take a look at some astonishing figures. Among the world's 100 highest bridges, an astounding 81 are located in China, including some projects that are still under construction. While China every day is making amazing progress, achieving real results for technology, infrastructure, improving the nation building and working hard to improve the standard of living for the people. China next-door neighbor India on the west border is always busy with their ton of boastful hypes, self-praise on their leadership, chanting superpower, dreaming of replacing China as world manufacturing country, but with not much real achievement, progress, and result. For instance, India plans to construct a railway bridge taller than the Eiffel Tower, named the Chenab Railway Bridge, located in the Jammu and Kashmir region. The bridge is designed with a lifespan of 120 years and a height of 359 meters, surpassing the Eiffel Tower by 35 meters. Construction on this bridge began as early as 2002, with the original completion target set for 2009. However, it was abruptly halted in 2008. The project remained at a standstill. In 2010, construction resumed, with Indian media claiming it would be finished by 2016. However, reality proved astonishing. By 2016, only the Bach Bridge pier of the Chenab Railway Bridge had been completed. Full construction resumed in 2017, and due to various reasons, the planned completion was further delayed to 2019. This series of setbacks has led to a prolonged delay in the completion of the Chenab Railway Bridge. The primary reasons include India's weak overall capacity, coupled with the high cost of construction materials, exacerbating India's already challenging economic situation. Furthermore, India lacked experience and technical expertise in the construction process, resulting in frequent issues and a decline in construction speed. Ultimately, the Grand Bridge took 21 years to complete, and it is expected to be operational by 2024. In summary, although India's Chenab Bridge incorporates high-tech materials and advanced construction techniques, surpassing China's infrastructure prowess remains a formidable challenge. In comparison, China's construction of the Three Gorges Dam, a hydraulic project, has attracted widespread attention and is hailed as an unparalleled feat in hydraulic engineering. Besides, they still have the gut and not ashamed to belittle and criticizing China infrastructures are built like tofu. China's success must have made them very upset, jealous and frustrating that many of their media channels know a day we don't see negative news, fake news and propaganda reports bashing and mocking China like a dog barking at the neighbor daily. But the China just ignored the dog barking noises and keep moving forward to get their business done to achieve what they aim for. Without further ado, let's get straight to the point. Firstly, let's take a look at the super bridge built in China at a cost of nearly 800 million, the Yachi Bridge. This grand bridge stands atop a cliff at an impressive elevation of 434 meters, with a total length of 1,200 meters. So, what was the level of difficulty in constructing this bridge? With a magnificent main span of 436 meters and a total length of 971 meters, the Yachi Bridge is not only the world's largest continuous rigid frame bridge with a steel-concrete composite deck and a cable-stayed basket handle arch, but also the longest span high-speed railway bridge of its kind. The construction of the main tower's reinforcing steel used a groundbreaking method where steel was bound and formed into shape on the ground before being lifted and installed on the tower columns. The hydraulic climbing formwork employed a system with fewer pole rods, enhancing the appearance and quality of the tower columns' concrete. The connection of the bridge's steel truss arches involved precision welding and bolting, demanding extremely high machining and assembly accuracy, controlled to within millimeters. Any deviation exceeding 2 millimeters could result in misalignment of the bolted joints. The entire bridge required approximately 130,000 cubic meters of concrete, and the steel used in the truss beams amounted to over 16,000 tons. In the gorge where the bridge is situated, instantaneous wind speeds can reach up to force 10. The cable tower's top is 110 floors above the Yachi River surface, posing extremely high construction safety risks. American engineers boldly claimed that China couldn't complete such a project due to its complexity. However, Chinese engineers overcame numerous challenges, successfully completing the Yachi Bridge, showcasing the dominance of Chinese bridge construction technology and marking a significant milestone in the development of the Chengdu-Guiyang high-speed railway. From the ancient Xiao Bridge to the modern Kong-Zhuhai-Macau Bridge, China's bridge construction technology has been at the forefront of the world. Each bridge is an epic, recording the hard work and creative wisdom of the Chinese people. From the ancient Xiao Bridge, with its unique arch structure and exquisite stone carving art, showing the wisdom and ingenuity of the ancients, to the modern Kong-Zhuhai-Macau Bridge, with its huge scale, complex technology, and innovative concept, it has become a miracle in the history of world bridges. This bridge not only connects Hong Kong, Macau, and Zhuhai but also demonstrates China's leading position in modern bridge construction. The Hong Kong-Zhuhai-Macau Bridge travels across the sea. It gradually descends into the water, and at the terminus where it submerges, 33 giant tunnel tubes were sunk sequentially to the seabed to form a 6.7 kilometers long undersea tunnel. The tunnel not only leaves sufficient space on the sea surface, but also greatly reduces the structure's impact on sea currents. The two flanking artificial islands ensured a seamless transition between the undersea tunnel and connecting bridges. With such combination, the longest sea-crossing bridge in the world literally paves a path across the vast sea. Besides, the Shenzhen-Zhongshan Bridge under construction is also a great miracle in the history of bridge construction in China. The Shenzhen-Zhongshan Bridge connects Shenzhen and Zhongshan City in Guangdong Province, where the 270-meter-high bridge tower supports the Lingdingyang Bridge with a span of up to 1666 meters, becoming the bridge with the largest span in China's sea area. China's bridge construction technology is truly amazing, especially in complex terrain conditions, such as high mountains and deep sea currents. Chinese bridge engineers have created one miracle after another with exquisite technology and unremitting efforts. They have not only solved technical problems but also demonstrated to the world the grandeur and magnificence of Chinese bridges. So far, China has more impressive bridges than any other country. But have you ever thought that each bridge has its own unique story? The Beipan River Bridge. The Beipan River Bridge is located at the junction of Yunnan and Guizhou provinces and is one of the highest bridges in the world, with a height of 565 meters from the bridge deck to the river surface, equivalent to the height of a 200-story building. However, this bridge has been labeled as a knockoff by American media. Some American experts publicly questioned and ridiculed the construction speed of this bridge, believing that China could not have built such a spectacular project solely on its own efforts and must have copied American designs and methods. This kind of statement not only lacks understanding of China's construction level and innovation ability but also carries a sense of disdain. China's development is truly amazing. Most Americans don't have a clue what it is like over there. The USA should be inspired by China and seek to learn from them rather than demonize them and make them America's enemy. China is a great example of hard work and dedication, which used to be American values. China is also a great example of what is possible when government focuses its resources in the best interests of its people, rather than focusing resources on going to war with the rest of the world. So, is the Beipan River Bridge really like that? Does China really not have the ability to build such a bridge? Let's uncover the truth together. China has a long history and rich experience in bridge construction, achieving many independent design and technological achievements. China is the hometown of bridges, with the largest number of bridges in the world and a vast scale. Bridge construction is an important support for China's economic development and the essence of China's engineering technology. Americans were once unwilling to believe that in their eyes still backward China, they could build such amazing bridges in just 3 years. The results of the expert group's on-site inspection exceeded their imagination. China not only completed the construction of this bridge in 3 years, but also broke several world records. The Beipan River Bridge, with a total length of 1,341.1 meters and built to a dual carriageway standard, was designed for a speed of 80 kilometers per hour and cost 1 billion yuan. It was constructed using a variety of advanced technologies, giving it a strong sense of science and technology. Since its completion, the bridge has not only optimized the transportation environment between the two locations but also ended the history of no high-speed access between Shanwei and Zhuhaicheng. However, before the construction of this bridge, due to the complex terrain and harsh climate in the Beipan River area, combined with the fact that the Yunnan-Guizhou Plateau is a mountainous region with rough roads, residents on both sides could only rely on walking to travel between the two locations, leading to very backward economic development. To improve this situation, China decided to build a bridge across the canyon between the two locations. From then on, the Beipan River Bridge began to take shape. However, in the early stages of the project, it sparked many doubts and ridicule internationally. This was also due to the extremely harsh environment at the junction of the two provinces, with many caves and a high degree of construction difficulty and danger. At the same time, the distance from the bridge deck to the river surface is 565.4 meters, equivalent to the height of a 200-story building, higher than the highest Millau viaduct in France by nearly 100 meters. For China, this was undoubtedly a new challenge. Faced with these world-class challenges, how did China overcome them one by one? First, the location of the bridge is in a karst landform, and the 10 kilometers of mountains along the river are densely packed with limestone, with very poor hardness, unable to bear the weight of the bridge, so the bridge deck had to be raised. However, it is easy to have collapses of caves during construction, which greatly affects the construction. To ensure the stability of the bridge, Chinese engineers initially planned to build a suspension bridge, but transporting a large amount of materials faced difficulties. Therefore, the technical team overturned this idea and adopted a method of connecting the bridge deck by supporting steel cables through bridge piers, which is also called a cable-stayed bridge, and then pulling up the bridge deck with steel cables. The Banan River Bridge used a total of 244 steel cables with a diameter of only 5.1 millimeters, with a tensile strength exceeding 1860 megapascals, far exceeding international standards. After solving this problem, a new challenge arose, namely the anchoring problem. Regardless of the type of suspension bridge built, it will use the core component of anchoring, which is equivalent to the main beam of the suspension bridge. If the Banan River Bridge also uses this component, it would be necessary to fill the caves in the mountain and build a concrete anchoring area of over 10,000 square meters on both sides of the bridge, but doing so would greatly damage the balance of the mountain. To avoid damaging the mountain and still be able to build the suspension bridge, experts proposed a bold new approach, which was to let the Banan River Bridge adopt the design of auxiliary bridge piers, with the bridge piers on both sides as the fulcrum. However, this design brought new challenges to the height of the bridge. Even with innovative design, the bridge deck is still nearly 100 meters above the ground. At 2,461 feet, the spire is taller than the two Eiffel Towers and the Statue of Liberty combined. And the bridge deck has to bear more than 52,310 tons, which is equivalent to the weight of 5 Titanic ships combined. As a result, the bridge piers not only have to play a supporting role but also have to withstand the huge frictional force generated by the horizontal movement of the steel truss, which is extremely difficult to achieve. After many discussions, Chinese engineers decided to abandon this approach and adopted the method of longitudinal splicing, and conducted multiple computer simulations to ensure the safety of this plan. When connecting the steel beams with bolts, the construction team made a decision that broke with tradition, using plastic bolts. This move was also met with many doubts, but it proved to be a far-sighted decision. After many comparisons and tests, Chinese engineers found that plastic bolts were superior to iron bolts in terms of wear resistance and rust resistance, greatly improving the wind and earthquake resistance of the bridge and extending its service life. It can be said that this small piece of plastic not only solved the 300 billion project problems overseas, but also reduced the later maintenance costs. The Banan River Bridge also used a large number of black technologies, using the latest scientific research results, conducting simulation analysis through computers, and conducting preliminary demonstration through 3D modeling. After 3 years, the Banan River Bridge was completed in 2015 and opened to traffic smoothly. In 2018, it won the Nobel Prize at the 35th National Bridge Conference and was awarded the title of the world's tallest bridge, the Sidu Bridge. The Sidu Bridge is a magnificent cable-stayed bridge that has become the focus of attention worldwide due to its unique construction method. In the history of bridge construction, it was the first time that rocket technology was used to transport the lead steel cables, completing this unprecedented feat. The 2 heavy-duty steel cables of this bridge, like 2 giant dragons, lie above the gorge, woven from tens of thousands of tons of high-strength steel wires, incredibly sturdy, firmly fixed on the bridge piers on both sides. These steel cables hang down from the main cables, connecting the bridge deck like countless lifelines, carrying vehicles and pedestrians back and forth, ensuring their safe passage. However, during the construction of this bridge, engineers faced enormous challenges. Before laying the main cables, a lead steel cable had to be sent to the opposite side of the gorge. This task seemed simple but was actually extremely difficult. The span of the Sidu Bridge reaches over 1,000 meters, and the gorges on both sides are steep and rugged, making ground transportation impossible. At the same time, due to the complex terrain of the gorge and the strong wind, Helicopters were also unable to safely transport the lead steel cables from the air. Faced with this problem, Chinese engineers did not back down. After careful consideration, they finally came up with a bold and innovative solution, using rockets to transport the lead steel cables. This idea may sound incredible, but with the ingenious ideas and bold innovations of Chinese engineers, it became a reality. Engineers contacted nearby military units and obtained a military rocket. Then, they replaced the explosive cord with the lead steel cable, and after careful planning and preparation, the rocket successfully delivered the lead steel cable to the opposite side of the gorge. This innovative solution not only solved a major problem in the construction of the bridge, but also fully demonstrated the wisdom and innovative ability of Chinese engineers. The construction of the Sidu Bridge is the result of the ingenious ideas and bold innovations of Chinese engineers, which has had a huge impact internationally. Many international bridge experts have said that they had never thought of using rocket technology to build a bridge before. This bridge is not only a transportation hub connecting both sides, but also a symbol of the wisdom and innovation of Chinese engineers. It showcases China's leading position and strong capabilities in the field of bridge construction to the world, and provides valuable experience and insights for future bridge construction. The construction of the Sidu Bridge not only demonstrates the outstanding innovative ability of Chinese engineers, but also brings a revolutionary solution to the global bridge construction field. Although Chinese engineers have made this technology public, due to its high requirements and difficulty, no other bridge worldwide has yet been constructed using the same technology. This has allowed the Sidu Bridge to maintain its status as the only bridge in the world built using rocket technology. This achievement has not only won international reputation for Chinese engineers, but also made Western countries, which once underestimated Chinese technology, take notice. They have to admit that China's innovative strength has taken the lead in the world. As a brilliant pearl of scientific and technological innovation, the bridge has established a new image for China on the global stage, showcasing its increasingly strong national and technological capabilities. Pingtan Bridge, China's symphony of steel and sky. The Pingtan Bridge gracefully arcs over the Sidu River Valley, breathing life into the landscape. Rising to a height of 332 meters, it reaches towards the heavens with unyielding resolve. A marvel of multi-span engineering, its 2,100-meter span dances across the abyss, a testament to human audacity. Woven into the tapestry of modern China, this bridge transcends mere utility, becoming an ethereal link between human aspirations and the natural world. The world's longest sea-crossing bridge, the Kong-Zhuhai-Macau Bridge, has been opened to traffic, with a total length of 55 kilometers, hailed as one of the 7 wonders of the modern world. The world's highest bridge, the Banan River Bridge, spans Guizhou in Yunnan, with its bridge deck reaching 564 meters above the valley floor, equivalent to the height of a 200-story building, breaking the record for the highest bridge deck in the world. The Danyang Grand Bridge from Nanjing to Shanghai Hongqiao is the world's longest bridge, with a total length of 164.851 kilometers, still holding the Guinness World Record to this day. In terms of infrastructure construction, China is also leading the way. The mileage of highways in operation has reached 131,000 kilometers, ranking first in the world. The total operating mileage of high-speed railways exceeds 31,000 kilometers, also ranking first in the world. China has 800,000 highway bridges, 200,000 railway bridges, totaling 1 million bridges, ranking first in the world. The number of communication base stations is as high as over 5 million, more than 20 times that of the United States. The mileage of subway lines in operation is 3,095 kilometers, far exceeding the United States' 1,100 kilometers, also ranking first in the world. As for high-rise buildings, China has 347,000, including over 6,000 super high-rise buildings over 100 meters, far surpassing other countries in quantity. These figures are not only astonishing but also a true reflection of China's infrastructure strength. demonstrating its unparalleled power and achievements in the field of infrastructure. The Forbidden Zone Bridge, Pingtan Straight Road Rail Dual-Use Bridge. The Pingtan Straight Road Rail Dual-Use Bridge, a marvel in the history of bridges in China and even the world, finally opened to traffic in December 2020. After 7 years of arduous construction, it spans the strait like a giant dragon, connecting the prosperity and hope of both sides. As China's first cross-sea road rail dual-use bridge in history, and also the world's largest road rail dual-use bridge, its completion not only demonstrates China's strength in bridge construction but also serves as a powerful proof of Made in China. The main structure of this bridge is ingeniously divided into 2 levels. The lower level is a busy 2-way railway, with trains shuttling through at a speed of 200 kilometers per hour, like a flowing landscape. The upper level is a spacious 2-way expressway with a speed limit of 100 kilometers per hour, featuring 6 lanes, providing a safe and smooth passage for vehicles. This unique design not only realizes the parallel transportation of railways and roads, but also demonstrates China's innovative spirit in bridge design. However, the harsh natural environment of the Pingtan Strait posed unprecedented challenges to the construction of the bridge. It is not only one of the world's 3 major wind corridors, but also experiences over 300 days of wind above level 6 every year, making it extremely difficult even for ships to pass through. The deep water and high waves and winds have made this area a forbidden zone for bridge construction. However, it is precisely this forbidden zone that has inspired the Chinese workers' determination and determination. More than 5,000 builders have silently dedicated 7 years of their time here. They have worked day and night, overcoming countless difficulties and technical problems. They have used sweat and wisdom to write a brilliant chapter in Made in China, proving to the world China's top strength in bridge construction. The opening of the Pingtan Straight Road Rail Dual-Use Bridge is not only a milestone in the history of China's bridge construction but also a vivid portrayal of the spirit of Chinese workers. Today, this bridge has become an important transportation hub connecting both sides, injecting new vitality into the economic and social development of the Pingtan region. It stands tall like a monumental monument, witnessing the indomitable spirit of Chinese workers in overcoming difficulties and demonstrating to the world the infinite possibilities of Made in China. In the days to come, the Pingtan Straight Road Rail Dual-Use Bridge will continue to carry people's hopes and dreams, bridging the gap across the strait and connecting to a better future. The Green Passage in the Desert Xinjiang-Hotan Railway. In the remote northwest desert, a great feat is unfolding. In just over 3 years, the Hotan-Ruoqiang Railway has risen from this barren land like a giant dragon, spanning the Taklamakan Desert and shortening the journey for the people of Hotan by more than 1,000 kilometers. Imagine the construction site of the Darin Desert Highway in Xinjiang, where more than 30 large bulldozers traverse the sand hills, flattening the towering sand dunes into roadbeds. The roaring sound of the machines, like a war song in the desert, is awe-inspiring. This under-construction Darin Desert Highway is 151.764 kilometers long, not only an important part of the main channel in southern Xinjiang but also a lifeline connecting southern Xinjiang with the northwest and southwest regions. The Taklamakan Desert, known as the Sea of Death, is a forbidden land with perennial high temperatures and sandstorms. However, the workers of the Hotan-Ruoqiang Railway, with their perseverance and resilience, have pierced through this desert that has been isolated for thousands of years. From Hotan City in the northwest corner of the Taklamakan Desert to Ruoqiang County in the southeast corner, there are 22 railway stations along the route, with a length of 825.476 kilometers. Among them, 524 kilometers of railway traverse extremely harsh desert areas, accounting for 65% of the entire route. The hardships during construction are indescribable. Railway workers not only face challenges such as supply shortages and hot weather but also the constant threat of life-threatening situations. In the Taklamakan Desert, 7 months of the year are spent in sandstorms. When the sandstorm strikes, the workers can only lie on the ground, tying themselves and the railway equipment together with ropes to prevent being swept away by the sand. Such scenes have become part of the daily life of railway workers. The ingenuity of Chinese railway workers is also astonishing. To overcome the severe water shortage for concrete curing in the area, more than 400 bridge piers along the entire railway line are assembled using prefabricated pier body assembly technology. These giant bridge sections are not built on-site but are prefabricated in distant factories and then transported to the construction site for installation. This flexible and ingenious method not only reduces the work steps at the construction site but also ensures the quality of the bridge piers. What is even more admirable is that the railway workers proposed an advanced concept of building railways in the desert, controlling sand first. They have built nearly 50 million square meters of grass grids along the railway lines and planted nearly 13 million shrubs and trees. These green barriers not only beautify the desert landscape but also serve as windbreaks and sand fixers. As the world's first railway to pass through a desert, the Hotan-Ruoqiang Railway not only proves that China's railway construction technology has reached the world's top level but also demonstrates the spirit of the Chinese people who are not afraid of difficulties and are courageous in exploration. This green passage is not only a transportation artery connecting southern Xinjiang with the northwest and southwest regions, but also a road of hope forged with life. In Fujian, China, workers completed the construction of a train station in just 9 hours. Wow, this is the speed of China that attracts the world's attention. The renovation project of Longyan Railway Station on the Nansan-Long Railway in Fujian was completed in just 9 hours, thanks to the joint efforts of over 1,500 workers and more than 100 machines. This speed is astonishing and has attracted global attention.
How the Chinese do these things, they were able to build a whole new station in the space of 9 hours. By flooding it, thousands of workers. We should be much more imaginative about getting infrastructure in instead of condemning people to being isolated in remote areas.
Nice.
This remarkable construction speed not only reflects the hard work and efficient collaboration of Chinese workers, but also demonstrates China's strong capabilities in infrastructure construction. Elon Musk, the Iron Man of Silicon Valley, also retweeted and praised the speed of China's construction, saying that it is 100 times faster than that of the United States. This is enough to show that the speed of China has become a hot topic worldwide. Americans have to admit that, looking at the world, no country can match China's astonishing speed. All of these prove that the Chinese people are becoming stronger and stronger in building world-class projects. Over the river in Chongqing, a heart-stirring aerial ballet is unfolding. 5 magnificent large-span bridges, resembling 5 graceful dancers, are performing a synchronized rotational movement in the same area and on the same plane. These 5 bridges have a total length of 383.5 meters and a total weight of 21,500 tons, equivalent to the total weight of 15,000 cars. As the bridges begin to slowly rotate, it seems as if the entire sky is moved by their motion. The rotation process resembles a magnificent aerial dance, with the bridges and their reflections on the river surface creating a splendid picture. At this moment, the bridges are not just channels connecting the 2 banks, but a perfect fusion of art and engineering. This aerial ballet of the 5 bridges not only sets a new world record, but also showcases the remarkable achievements of bridge construction in China. It proves our leading position in the construction of large span cluster rotational bridges and highlights our innovative spirit in the field of bridge engineering. The rotational movement of these 5 bridges is not only a technological breakthrough but also a visual feast. Their trajectories in the air, like beautiful arcs, adorn the magnificent scenery of the river in Chongqing. This aerial ballet is not only a triumph of engineering but also an artistic display that leaves us in awe. Sidu River Bridge, China ascending to an astonishing 496 meters. The Sidu River Bridge reaches towards the heavens, leaving the world below in awe. Its journey from conception to reality, including the ingenious rocket-assisted wire installation, captures the essence of human perseverance. A linchpin in the G50 Huyu Expressway, it defies gravity and expectations, uniting regions with its ethereal embrace. A passage to progress, Qingshui River Bridge, China, the Xiao River Bridge emerges as a soaring ode to progress, breaching the Xiao River Gorge at an elevation of 406 meters. Its creation, intricately linked to the Guiyuan Expressway, has transformed distances and perspectives, embodying the fusion of innovation and pragmatism. In its graceful span of 1,130 meters, it becomes a conduit between time-honored traditions and modern convenience. Get ready to be amazed by one of China's tallest bridges, the Pingtan Bridge, a marvel of engineering in Guizhou Province. This cable-stayed viaduct stretches for 2 kilometers, spanning steep valleys and significantly reducing travel time between Pingtan and Luodian. Its 3 towers, each towering like skyscrapers, reach heights of over 300 meters, equivalent to a 110-story tall building. Driving on this massive bridge is both thrilling and awe-inspiring. Now, let's head to Guizhou Province to explore the remarkable Yachi Bridge, a high bridge marvel that facilitates efficient travel in the rugged mountainous terrain of the region. Guizhou Province boasts nearly 1,000 bridges with deck heights exceeding 100 meters, an achievement unmatched by any other country. For example, the Yachi Suspension Bridge has significantly reduced travel time between Guiyang City and Huangping County, cutting it from 3.5 hours to just 1 hour. Often referred to as the Stilt Bridge, the Yachi Bridge's pier lengths reach an astounding 110 meters, nearly twice as long as San Francisco's famous Golden Gate Bridge. As for the bridge deck, it soars over 300 meters above the turbulent waters of the Xiao River, making the crossing an exhilarating and at times terrifying experience. The Kong-Zhuhai-Macau Bridge is nothing short of a pinnacle achievement in sea crossing bridge construction worldwide. The world's longest sea crossing bridge, spanning 55 kilometers, it's objectively 20 times the length of San Francisco's Golden Gate Bridge. This marvel has reduced travel time from Hong Kong to Zhuhai and Macau from 3 hours to just 45 minutes, reshaping transportation and making significant contributions to the economy. However, the journey of constructing this bridge was filled with controversies. During its construction, nearly 20 workers lost their lives due to hazardous conditions. In 2017, a corruption scandal rocked the project, revealing that a Chinese company had manipulated concrete test results instead of conducting proper safety checks. Some international civil engineers also raised concerns about the bridge's resilience to strong waves and typhoons. Although the government disputed these claims, American engineers remained adamant about the bridge's potential dangers. Nevertheless, the completion of the Kong-Zhuhai-Macau Bridge marks a new milestone in Chinese bridge construction, showcasing the extraordinary prowess of Chinese engineering technology while reminding us of the importance of safety and transparency in large-scale projects. The Longjiang Suspension Bridge, entering the earthquake-prone region of Yunnan Province, connects Baoshan and Tingchong through a series of roads, tunnels, and the towering Longjiang Suspension Bridge. This bridge is perched at a daunting height of 300 meters above ground and is equipped with advanced movable joints designed to withstand powerful earthquakes. Yunnan's history of seismic activity has caused significant destruction in the past, making the safety features of this bridge critically important. Imagine experiencing an earthquake at such a height. It's nerve-wracking for anyone, but the Longjiang Suspension Bridge is just the beginning. So, what about bridges that have collapsed before? The Longjiang Suspension Bridge showcases the pinnacle of technology, leveraging engineering expertise to overcome nature's challenges and setting a solid example for future bridge construction. Zhangjiajie Glass Bridge is one of the world's most spine-chilling tourist attractions. Experience an adrenaline rush on this bridge, which stretches over 430 meters and hovers 300 meters above the ground. Carefully cleaned glass panels offer a clear view of the scenery below, providing an unforgettable photo opportunity for thrill seekers. Those with daring spirits will want to visit this terrifying glass-bottom bridge in China, as it promises an exciting adventure. Standing on this bridge, you can overlook breathtaking natural landscapes, but for those with a fear of heights, it may be a significant test. When you step onto this bridge, you'll embark on an unprecedented adventure, one that will be etched in your memory. This is Qingdao. This young coastal city has now become the third largest city in northern China in terms of economic output, ranking just behind Beijing and Tianjin. It is nestled by the coast and vying for attention with an explosive twist. That's right. Beneath the waves is right at the construction site of the Xiao Bay second undersea tunnel, soon to be the world's lengthiest underwater highway. But Qingdao isn't new to smashing records. A dozen years back, they dropped the mic with the Xiao Bay Bridge and Tunnel, stealing the spotlight as the planet's longest cross-sea bridge and China's reigning underwater tunnel champions. So, what's cooking with this new world record and Qingdao's sudden passion for sea-spanning structures? Well, let's rewind and appreciate Qingdao's cozy embrace of Xiao Bay, which, believe it or not, was once just an ordinary basin. A mere 11,000 years ago, a bit of sea level drama transformed it into the spectacular Xiao Bay we see today. With its deep, expansive harbor and impeccable geography, Qingdao proudly houses the world's fourth largest port, Qingdao Port, and it's not just a port, it's the heart of the city. On the bay's east side, you'll find the old city of Qingdao, while to the west coast new area, affectionately known as Huangdao, has taken shape. 3 decades ago, crossing the bay meant leisurely ferry rides, taking a whole hour to get across, not exactly a whirlwind. Things got a bit speedier with the Coastal Bay Highway, trimming the journey to a brisk 50 minutes. But the real game changer arrived in 2011 with the Xiao Bay Bridge and Tunnel, slashing travel time to a jaw-dropping 6 minutes. Suddenly, Qingdao's free trade zone, economic development zone, port hubs, and the legendary Qingdao International Beer Festival all relocated to the West Coast new area. Cross-bay traffic went through the roof, with nearly 200,000 vehicles making the journey daily. To earn its title as a true bay city, Qingdao needed a fresh cross-sea passage, one that doesn't tick off Poseidon, scoffs at strong winds and fog, and keeps the travel vibes alive around the clock. Enter the Xiao Bay second undersea tunnel now under construction. But it's not without its challenges. Stretching for a whopping 14.37 kilometers, it boasts 6 lanes in each direction and plummets to depths of 115 meters below sea level. Talk about tunneling into the unknown. This tunnel has to face 2 distinct rock formations. On the Huangdao side, it's all about rugged granite, while Qingdao's soft gray limestone and sandy layers add a twist. Plus, there are 22 faults lurking around, with the Big Daddy named Sanko Fault, a behemoth spanning over 200 meters. It's like a line in the sand, separating flat plains in the west from hilly terrain ruled by Laoshan Mountain in the east. Now, how do you drill through this geological maze? There's the drill and blast method, great for both hard and soft rock. Then there's the shield tunnel boring machine, TBM, method and the immersed tube method. Immersed tubes are costly and messy for the environment, so they're out. Faced with a cross-sectional diameter of 15.6 meters and water depths exceeding 100 meters, the TBM construction method carries significant risks, and therefore, it is also ruled out. So, considering the distribution of rock formations, combining drilling and blasting with shield tunneling is the most reliable construction method. Start with drill and blast, a real rock and roll show, with engineers drilling 254-meter deep holes into granite faster than you can say explosives. Speaking of which, those sausage-looking explosives fit snugly into the holes and, with precise placement, blast the rock into shape. There's more to do, as these blast holes need 3 layers of reinforcement, inner and outer concrete jackets with a waterproof layer in between. And there you have it, a tunnel in the making. Yet, the real cliffhanger isn't the rock, it's the lurking faults, waiting to crash the party. The fragile rock here demands caution, or a floodgate of groundwater or seawater could wash everything away. So, radar scouts ahead, and if conditions look dicey, holes are drilled and cement injected to fortify the fissures. This solid barrier not only blocks water but strengthens the tunnel, letting it inch forward through the colossal Tsanko Fault at a slow and steady pace of 2 to 3 meters per day. Now, for the softer limestone zones, it's time for the shield tunneling method. Behold the legendary tunnel boring machine, TBM, an 8-meter-wide juggernaut with a cutter head that eats rock for breakfast. It grinds boulders into mud and pumps them out through pipes. Simultaneously, the TBM hoists up concrete segments to create a seamless tunnel lining. It's like a giant palm holding up a 1-ton weight, a true showstopper. Afterward, this colossal machine gets disassembled, transported to a 30-meter deep pit, reassembled, and heads off to conquer the seabed. But here's the kicker, finishing the main tunnel doesn't mean the end of the adventure. What about exhaust gases? What if construction drags on, or heaven forbid, accidents occur? Enter the hero of our story, the service tunnel. It's not for regular traffic, but it's the control center for tunnel wizardry, maintenance, pipelines, and emergency escapes. It's the tunnel's hidden superhero, working side by side with the main tunnels. And the big reveal? How do those eastbound and westbound tunnels meet? Imagine an epic chamber beneath the sea, a 30-story behemoth serving as the tunnel's junction and a launching pad for the TBMs. It's not just any chamber, it doubles as a ventilation hub, a feat most undersea tunnels manage with towering ventilation buildings. But not here. They're keeping things marine-friendly by placing those towers on land. The service tunnel, free of vehicles and exhaust, acts as the air channel, splitting the 10-kilometer ventilation distance into 2 neat segments. By the end of 2027, this colossal tunnel will be ready to steal the show. And when you walk through it, don't expect flashy lights or red carpets. It's all about subtlety, hidden beneath the seabed, letting marine life and shipping carry on undisturbed. In a speech, Professor Ellison from Harvard University commented on the speed of China's development, saying, "Everything is progressing so quickly that we don't even have time to be amazed."
China has actually soared. It's meteoric. All this has happened so fast, we haven't yet had time to be astonished.
To illustrate his point, Professor Ellison gave an example. In the state of Massachusetts, USA, there was a bridge that underwent repairs starting in 2012 with an estimated duration of 2 years. Well, guess what? Professor Ellison said.
In 2014, they said it wasn't finished. In 2015, they said it would take 1 more year. In 2015, they said it's not finished. We're not going to tell you when it's going to be finished. Finally, last year it was finished 3 times over budget.
On the other hand, there is a bridge in Beijing, China called the Chenab Bridge, which is several times larger than the American bridge. In 2015, the Chinese decided to renovate it. Professor Ellison asked,
How long did it take for them to complete the project? 2015. What do you bet? Take a guess. Okay. Take a look. The answer is 43 hours. Now, of course, that couldn't happen in New York. Yes.
Yup, you heard that right. Just 43 hours. But my friends, that's just the tip of the iceberg when it comes to China's infrastructure prowess. Fast forward to 2018, and China's showcasing its strength once again. Due to conflicts with a newly constructed route, the Longyan railway station in Fujian province had to be demolished. After extensive discussions, experts decided to directly move the entire station. The plan was quickly finalized, and construction began. To avoid disrupting normal traffic the following day, the project was carried out at night with 1,500 workers and countless construction machines. China completed a whopping 1.5-kilometer-long infrastructure project in less than 9 hours. When foreign media caught wind of this, it caused quite a stir. Let's continue to explore one of the ongoing epic engineering projects in China, the Pingtan Grand Canal. The canal starts at the mouth of the Xiaojing River in the West Jinsei Reservoir, spanning approximately 135 kilometers in total length. The overall route of the project is divided into 4 sections: Shaping River section, Watershed Ridge section, Qinzhou Mainstream section, and Estuary section. Among these, the Watershed Ridge section requires manual excavation, connecting to the Qinzhou Mainstream through Luwu Town in Lingshan County, Qinzhou. The waterway is constructed to a first-class standard for inland water navigation, allowing for the passage of 5,000-ton inland vessels. The Grand Canal eventually flows into the Bibu Gulf through the Xiaojing estuary. Upon completion, this project will significantly shorten the maritime route for goods from the southwest region of China by over 560 kilometers compared to exiting through Guangzhou. This new canal, resembling a soaring dragon, is a crucial component of the West Land Sea New Channel and marks the first inland canal since the establishment of the People's Republic of China. To construct this supersized canal, the Chinese government has invested a staggering 72.7 billion yuan. In the process, Chinese engineers are tasked with excavating approximately 329 million cubic meters of earth and rock, a quantity 3 times that of the Three Gorges project. The excavated materials will be utilized for purposes such as land reclamation, ecological restoration, and infrastructure development, contributing to China's sustainable development. The Pingtan Grand Canal can be described as a monumental canal construction project. On the construction site, vehicles rumble back and forth with the deafening roar of machinery, showcasing the significant importance China places on this canal's construction. With a total length of about 140 kilometers, the Pingtan Grand Canal can accommodate vessels of up to 5,000 tons. Once completed, the canal will not only facilitate navigation but also serve functions such as water supply, irrigation, flood prevention, and improvement of the water's ecological environment. Throughout history, the Chinese people have never shied away from challenges. Millennia ago, in an era with underdeveloped construction technology, China built the Great Wall, a wonder of the world. In modern times, despite being besieged by Western powers, China successfully constructed the Jingjiang Railway and the Qiantang River Bridge. These remarkable feats remind us that if miracles had a color, it would undoubtedly be Chinese red. It is understood that the Pingtan Grand Canal is expected to be completed and navigable by the year 2027. Next, we arrived at the construction site of the Huajiang Canyon Bridge. This bridge spans the Huajiang Grand Canyon, famously known as the world's Great Rift. The bridge piers are strategically positioned at both ends of the mountain range, and the central section of the bridge is entirely suspended in mid-air. It is a single-span steel truss cable-stayed bridge. The Huajiang Grand Canyon stretches approximately 80 kilometers, making it the longest canyon in China. Within the canyon, towering peaks and deep river valleys create a nearly 1 kilometer relative height difference, earning it the title of the Earth's crevice. Constructing a bridge in such challenging terrain comes with numerous difficulties. The highest tower of the bridge, the design tower, reaches a height of 262 meters, equivalent to the height of more than 80 floors of a building. With a main bridge span of 1420 meters and a height of 625 meters from the bridge deck to the water surface, this colossal steel truss cable-stayed bridge is set to break world records. Upon completion, the bridge is expected to surpass the Beipanjiang Bridge and become the world's tallest bridge. The bridge is anticipated to be completed in 2025. It's worth mentioning that China's first expressway, the Shenyang-Dalian Expressway, was officially opened in 1988. Can you believe that within just over 30 years, China went from zero to becoming the global leader? It's like they hit the fast-forward button on development. Here's a fun fact. China consumed as much cement in 3 years as the United States did in nearly a century. That's how rapid changes have become the norm in China. However, if we want to talk about China's ability as an infrastructure maniac, We have to thank the United States for teaching China a valuable lesson. Back in the early days of China's founding, infrastructure wasn't exactly a top priority. After all, they had just emerged from a century of humiliation and were focused on overcoming poverty and weakness, making sure people had enough to eat. Meanwhile, the United States was flexing its infrastructure muscles with 400,000 kilometers of railways, 124,000 kilometers of highways, and engineering marvels like the Empire State Building and the Hoover Dam. In 1950, the US produced a staggering 87.85 million tons of steel, while China managed only 610,000 tons. But then, China's predecessors in the volunteer army faced off against the mighty United States. Picture this: during the Battle of Chosin Reservoir on December 5, 1950, the U.S. 1st Marine Division was on the run, desperately trying to escape. The Xiao Bay Bridge in Guderi was a crucial escape route, but guess what? The Chinese Volunteer Army had already blown it up. And every time the U.S. military engineers repaired the bridge, the Chinese soldiers would destroy it again. It was a battle of wills. But the U.S., with its powerful industrial capacity, managed to transport 8 sets of 8.8 tons of bridges from Japan within 2 days. And just like that, they swiftly constructed a massive all-steel 50-ton bridge. And then they swiftly withdrew. That scene left an indelible mark on our predecessors in the volunteer army. Since then, China realized that it must become stronger, or else it would be subjected to aggression. In 1953, with the end of the Korean War, China officially embarked on its first 5-year plan. From that moment on, China put in all its effort to catch up with the United States. If there was no money, they would eat one less meal. If there was no technology, they study hard and try their best to change. If there were no machines, the hands of Chinese workers became excavators, and their shoulders became cranes. In 1958, construction officially began on the Qinghai-Tibet Railway, the world's highest altitude and longest railway on a plateau. It traversed the Tanggula Mountains, reaching a maximum elevation of 5,072 meters. Most of the route was located in a zone of extreme conditions, spanning 550 kilometers of frozen soil. Once the frozen soil thawed, the roadbed would undoubtedly be damaged. To solve this problem, Chinese scientists employed methods such as building bridges to support the road, ventilating the roadbed, and using insulation panels. However, compared to frozen soil, the lack of oxygen, low temperatures, and ultraviolet radiation posed even greater challenges. For this purpose, China invested nearly 200 million yuan and established 115 medical support points along the railway, with over 600 resident medical personnel. Through their tireless efforts, since the start of the Qinghai-Tibet Railway, they have treated a total of 453,000 patients without a single death. This miraculous sky road took 26 years to complete and open for operation, opening up the previously isolated Qinghai-Tibet Plateau. It stands as a significant milestone in China's history of infrastructure development. Three Gorges Dam. The Three Gorges Dam is the largest hydroelectric power project in the world today, serving as the largest hydroelectric power station and a major hub for clean energy production globally. The total construction volume of the main structure of the Three Gorges Water Control Project is beyond imagination, with 102.83 million cubic meters of excavation for the foundation, 27.94 million cubic meters of concrete foundation, 31.98 million cubic meters of earth and rock filling, 256,500 tons of metal structure installation, and the installation of 34 sets of units with a capacity of 22.5 million kilowatts for the hydropower station. Except for earth and rock filling, all other indicators rank first in the world. The Three Gorges project has 3 main benefits, namely flood control, power generation, and navigation, with flood control considered the core benefit of the project. The navigation ship lock of the Three Gorges project is 6.4 kilometers long in total, with the main part of the ship lock being 1.6 kilometers long. It consists of double lines of 5-tier ship locks, making it the largest of its kind in the world, and possesses the greatest water level drop among ship locks worldwide. When the Indian Prime Minister saw the Three Gorges Dam project, he instantly lost his composure. In order to surpass China, they hired Japanese experts at high salaries, vowing to build a dam even more impressive than the Three Gorges Dam. However, they ended up with a slap in the face. They invested 220 billion rupees and spent 42 years, finally completing the dam in Jharkhand. But that day also became its anniversary of doom, as the dam collapsed just 4 seconds after it was opened. So, for India to think it can surpass China is simply wishful thinking. China's Sky Eye. China's significant scientific infrastructure, the 500-meter aperture spherical radio telescope, known as the Eye of China and named FAST in English, lives up to its name with its fast and highly sensitive observation capabilities. Located in Pingtan County, Guizhou Province, the Eye of China has a diameter of over 500 meters, equivalent to the size of 30 standard football fields. It outperforms the previously most advanced Arecibo Observatory in the United States. Unfortunately, due to the lack of funding and maintenance by the US government, the Arecibo Observatory telescope collapsed completely on the morning of December 1, 2020, after years of neglect. With this, the era of the Arecibo Observatory telescope, once a superhero in the world of astronomy, has come to an end. It is now replaced by China's 500-meter aperture spherical radio telescope. For FAST, a foreign expert gave high praise, considering the telescope to be a powerful tool for astronomers and one of the most significant contributions made by Chinese scientists, playing a significant role in future astronomical endeavors worldwide. During operation, the 500-meter aperture spherical telescope has observed more pulsars than the total observed by European and American countries, and has even captured extremely rare astronomical phenomena. As a crucial instrument in the Chinese astronomical field, FAST has not only broken the constraints on the development of China's astronomical endeavors, but will also play an even more significant role in the future, achieving more splendid accomplishments. 2011, and miraculously rose in just 5 years. Through the diligent efforts and superb skills of countless researchers, it was officially unveiled on January 11, 2020, revealing its powerful capabilities to the world. The size of this eye is staggering. The area of just its reflecting surface is equivalent to 321 acres of farmland, resembling a giant silver dish lying quietly among the mountains, capturing mysterious signals from the universe. Its sensitivity is so high that it is astonishing. Compared to the world's second-largest Arecibo Observatory, its sensitivity is more than 2.5 times higher. This means that through it, humans can see farther and delve deeper into the mysteries of the universe. The operational opening of FAST is undoubtedly a major breakthrough for humanity in the exploration of the universe. It is like a key that opens the door to the depths of the universe for us. With its help, humans can gain a more comprehensive understanding of the composition of the universe, conduct deeper research into the evolution of galaxies, and more accurately search for the existence of extraterrestrial life. Its existence greatly broadens humanity's view in the universe, allowing us to better understand ourselves and the world. FAST is not just a telescope but also a symbol of human wisdom and courage. It witnesses China's rise in the field of science and technology, demonstrating the firm determination and strong capabilities of the Chinese people in exploring unknown territories. In the days to come, it is believed that FAST will continue to reveal more mysteries of the universe, promoting the progress and development of human civilization. The most powerful single-unit hydroelectric generator set by Biheat Hydropower Station, known as the most powerful single-unit hydroelectric generator set, recently once again refreshed the milestone of global hydroelectric technology. On October 14 this year, after 72 hours of intense and orderly continuous trial operation, Unit 12 was successfully put into commercial operation, marking the official debut of the 13th million kilowatt class hydro turbine generator set of this magnificent hydropower station, and beginning to contribute green power to the global energy. Biheat Hydropower Station, a masterpiece of technology, is expected to install a total of 16 million kilowatt class hydro turbine generator units. At present, these generator units are not only of large scale but also leaders in single unit capacity. This is at present the largest underground cavern cluster in the world, with a total length approaching 217 kilometers. The largest cavern is 438 meters long, 34 meters wide, and 88.7 meters tall. Hence can easily accommodate 13 Boeing 737 aircrafts. They represent the pinnacle of China's independent research and development capabilities, demonstrating China's outstanding strength in the hydroelectric field. Although the total installed capacity of Biheat hydropower station ranks second in the world after the Three Gorges Dam, its efficient power generation capacity is not to be underestimated. It should be noted that the Three Gorges Dam has 32 hydro turbine generator units, while Biheat hydropower station has only 16. This stark comparison vividly demonstrates the high efficiency and excellence of Biheat hydropower station. Just 10 years after the construction of the Three Gorges Dam, Biheat hydropower station has achieved a doubling of its power generation efficiency, which is nothing short of a miracle. Today, all units of Biheat hydropower station have been put into operation, with a total installed capacity of 16 million kilowatts. Every year, this hydropower station can provide sufficient electricity for 75 million people to meet their daily life needs. It is also worth mentioning that Biheat hydropower station can replace the use of 19.68 million tons of standard coal annually, reducing CO2 emissions by up to 52 million tons. This is not just a hydropower station but also a huge environmental guardian, contributing significant green energy to our planet. On the global stage of hydroelectric technology, China has become a shining star. The successful operation of Biheat hydropower station not only demonstrates China's leading position in the field of hydroelectric power but also sets a new benchmark for the development of global hydroelectric technology. In the future, we have reason to believe that China will continue to create more miracles in the field of hydroelectric power, contributing more to global energy transition and environmental protection. In beautiful Xiamen, a world-shocking engineering feat has been successfully staged. A passenger terminal weighing 30,000 tons seemed to gain magical powers, shifting a full 288 meters and completing a spectacular 90-degree turn, becoming what people call the most incredible relocation. Imagine such a colossal object, as if alive, changing from facing east to facing north. The magnitude of this transformation is truly astounding. However, through the ingenious design and superb craftsmanship of Chinese engineers, all of this became possible. They utilized the innovative alternating stepwise pushing and lifting technology to create a dreamlike journey for this building's relocation. They cleverly poured concrete between the columns to form trays, lifting the massive building off its original foundation. Then, according to the predetermined shifting route, they carefully excavated pits and laid tracks, allowing the building to move smoothly and steadily on these tracks. 532 walkers were installed at the bottom of the building, as if giving this massive structure feet to walk on. To ensure that the building could reach its destination smoothly and safely, engineers also installed 603 sensors at key positions on the walkers to monitor and provide real-time feedback on their movements. If the pushing force error exceeds 2 millimeters, the system immediately issues an alarm and suspends operation, ensuring the safety and accuracy of the entire relocation process. Under the precise control of the engineers, the building steadily progressed at a speed of 7.5 meters per day. After 38 days of arduous efforts, it finally successfully shifted 288 meters and reached its designated location. This feat was not only certified by the Guinness World Records as the longest arc of overall building translation, but also the world's first long-distance, large-radius building relocation, undoubtedly the most incredible move in history. In the bustling city of Wuhan, a brand new hospital, Huashinshan Hospital, rose from the ground in just 10 days, becoming a crucial fortress in the fight against the epidemic. This is not just a hospital but also a vivid demonstration of China's infrastructure speed, drawing worldwide attention. Similarly, in the following 12 days, Liangshan Hospital was also completed rapidly, fighting alongside Huashinshan Hospital and contributing to the fight against the epidemic. The construction of these two hospitals not only showcases China's construction strength, but also embodies the tenacious spirit of the Chinese people in the face of difficulties. Faced with the sudden epidemic, the whole nation united as one, with everyone pulling together to fight against it. The rapid construction of Huashinshan and Liangshan hospitals is a vivid embodiment of this spirit. During the construction process, countless builders worked day and night, overcoming numerous difficulties, and with their sweat and wisdom, they wrote deeply moving anthems of the anti-epidemic struggle. Their hard work has won precious time for the fight against the epidemic and brought a new hope of life to the patients. The so-called construction madmen are just a group of kind and courageous people who, burdened with responsibilities and adversity, put on armors and charge on quietly in everyone's prayers. The completion of these two hospitals not only demonstrates China's infrastructure speed, but also embodies the firm belief and strong will of the Chinese people in fighting the epidemic. They are not only important strongholds in the fight against the epidemic, but also a symbol of the unity of the Chinese people in overcoming difficulties together. They have once again shown the world the speed and strength of China, as well as the firm belief and tenacious spirit of the Chinese people in the face of difficulties. Among global bridge construction, there is a widely circulated saying: before the 1970s, look to Europe and the US. In the 1990s, look to Japan. In the 21st century, look to China. This saying fully expresses China's outstanding performance in bridge construction. At present, the 5 highest bridges in the world are all in China. Among the top 20 bridges under construction or already completed globally, 15 are built in China. Behind China's frenzy in bridge construction lies advanced science and technology and a robust pool of talent. Without sufficiently advanced equipment and tools and the research abilities of Chinese engineers, achieving such accomplishments would be a far-fetched dream. For instance, the Kunlun No. 1, a 1,000-ton bridge erection integrated machine, represents a significant breakthrough in the construction of high-speed rail bridges. It is the world's first 1,000-ton bridge erection integrated machine with versatile uses and high levels of intelligence, saving significant time and resources in the construction of China's high-speed rail bridges. Let's take another look at an engineering feat in China's bridge construction: the Wongen Bridge rotation project in Fujian. The main tower and main beam of the Wongen Bridge weigh a total of 23,600 tons. Chinese engineers needed to rotate them counterclockwise by 21 degrees to reach the designated position as per the design. The construction method involving 2 rotations during the bridge's construction is a pioneering achievement in the field of bridge rotation worldwide. The rotating system can withstand a weight of 25,000 tons, equivalent to 2.5 Eiffel Towers. With the diligent efforts of Chinese engineers, the main tower and beam, weighing 23,600 tons, were precisely rotated counterclockwise by 21 degrees, achieving the world's first double rotation construction in the bridge construction field and showcasing China's exceptionally high standard in infrastructure development. Next, let's delve into China's railway construction. As of the end of 2020, China's high-speed rail network had reached an impressive length of 37,900 kilometers, ranking first globally. Just 5 years earlier, in 2015, the total length of China's high-speed rail was only 24,130 kilometers. As of February 2023, the high-speed railway mileage in China has reached an astonishing 44,345 kilometers. This rate of development is unparalleled in the world, with no other country achieving such progress. The success of China's high-speed rail can be attributed to its extraordinary technological capabilities. High-speed rail is an immensely complex mega-project that demands robust technological support across various aspects, including construction, vehicle manufacturing, operation maintenance, and signal control. China's train control technology is at the forefront globally. As early as 2004, China established a complete train operation control system capable of supporting trains running at speeds over 300 kilometers per hour. Additionally, China boasts the world's largest high-speed rail monitoring and control system and traction power supply data acquisition system, fully equipped to facilitate train coupling in large group operations. These cutting-edge technologies enable trains running at around 350 kilometers per hour to have a continuous power supply, an unparalleled feat. The successful operation of China's high-speed rail is closely linked to the support of China's robust power grid. Let's now explore China's state grid. While many may view it as a financially powerful state-owned enterprise, it goes beyond that. Indeed, the state grid's financial strength is undeniable. For instance, in 2016, its revenue reached a staggering $320 billion, with profits totaling $10 billion, making it the top company among China's Fortune 500 and second globally. However, these achievements are not solely due to their monopoly status, but are strongly underpinned by advanced scientific and technological capabilities. An excellent example of this is the ultra-high voltage transmission technology, in which China leads the world. As early as 2019, China completed the world's first UHV alternating current power line, providing a stable power supply to billions of people. Even in the challenging and remote regions of the West, where construction faces high costs and scarce labor, the state grid is dedicated to providing stable electricity, benefiting countless people nationwide. Furthermore, the state grid has been expanding its energy network overseas, with foreign investments exceeding $10 billion. Backbone energy networks invested in and operated by China's state grid can be found in 7 countries and regions, including Portugal, the Philippines, Brazil, and Australia. Moreover, the state grid has invested in power transmission projects in many countries and regions worldwide. It is worth mentioning that all these overseas investment projects have been profitable, with no recorded losses. Such technological prowess and service level are unparalleled worldwide. In addition to railways, China's road construction is equally astonishing. In just over a decade, from 2005 to 2017, China's expressway length surged to over 70,000 kilometers, with a total mileage of 123,000 kilometers, firmly securing its position at the top of global rankings. In comparison, the United States, following China, has a total mileage of only 103,000 kilometers. The development of China's expressways has significantly facilitated information exchange and trade, providing robust support for the booming express delivery industry. China's express delivery industry is highly developed, boasting efficient logistics and affordable prices, an achievement that is challenging to replicate in other countries. In China's rapid development of infrastructure in recent years, basic materials such as steel and cement have also played a crucial role. In 1949, China's steel production was a mere 150,000 tons, less than a pound per person on average, which was quite scarce. Today, China's steel and cement production has reached astonishing levels. For example, in 2015 alone, China's crude steel production reached 800 million tons, an increase of 450 million tons or 125.9% from 2005's 360 million tons. At the same time, China's cement production also ranked among the top 10 globally. Even in 2015, the rapid development of China's cement industry has left even the former world's richest person, Bill Gates, amazed, calling China the cement king of the world. These examples clearly illustrate China's impressive achievements in infrastructure in recent years. Next, let's explore how Chinese engineers install the main cable, weighing over 16,000 tons, on a suspension bridge and ensure its 100-year lifespan. People are curious about how the slender main cable on a suspension bridge can bear the weight of tens of thousands of tons without breaking. How do engineers install the main cable over the vast Yangtze River? And how do they guarantee its 100-year lifespan? Taking the Wufingshan Yangtze River Bridge in Zhenjiang, China, As an example, this typical suspension bridge has a main span of 1,428 meters, with a river span of 1,092 meters. It requires 2 main cables, each weighing over 16,000 tons, with a tension capacity of 90,000 tons, equivalent to lifting a large aircraft carrier. The main cable is not as thin as it appears. It has a diameter of 1.3 meters and consists of 352 strands of lock bars. Each lock bar is 1,932 meters long and weighs 48 tons. Composed of 127 steel wires with a diameter of 5.5 millimeters. These lock bars are high-strength parallel wires treated with a corrosion-resistant zinc-aluminum alloy layer, reaching a strength of 1,860 megapascals. The main cable is extremely robust, eliminating concerns about breakage. Let's see how the main cable is installed over the wide river channel. Below the suspension bridge is a construction passage called the catwalk, used to install the main cable. Before installing the main cable, workers establish anchorages and thread the main cable through the top of the bridge pier using a guiding wire rope. Then, the cable is lowered onto a tugboat by the riverbank. The tugboat pulls the guiding wire to the opposite bridge pier and connects it with another guiding wire. Winches on both banks tighten the guiding wires to the appropriate positions, ensuring safety. Each catwalk requires the installation of 8 guiding wires. Once the catwalk is completed, the installation of the main cable can begin. The installation process of the main cable takes several months. Workers use a cable traction system to pull each lock bar from the northern bank's anchorage to the bamboo saddles at the top of the towers. The bamboo saddles evenly distribute the force on the main cable, change its direction, and transfer the pressure to the main towers. At the end of the main cable, there are anchorages where the cable is dispersed and connected to the anchoring system, relieving stress on the anchor bolts and ensuring structural safety. After the installation of the main cable, anti-corrosion treatment is applied to ensure its corrosion resistance over the 100-year lifespan. Engineers tightly wrap the 352 lock bars using a wire winding machine and heat shrink them with steel wires and high-performance composite wrapping bands, isolating the main cable from the external air. Additionally, an active dehumidification system injects dry air, reducing the humidity of the main cable and extending its lifespan. Through the aforementioned steps, the installation and anti-corrosion construction of the bridge's main cable is completed. In this way, through the efforts of Chinese engineers, a towering and majestic suspension bridge was built. The Jinshajiang Bridge, which crosses the Jinsha River in Yunnan. The main tower is 228 meters tall, with a vertical height of 479 meters, which is equivalent to the height of a 170-story building. The height from the bridge deck to the valley bottom is 335 meters, making it the second highest bridge in the world, surpassed only by the Beipan River Bridge. The Jinsha River Bridge is currently the world's largest cable-stayed bridge spanning a mountainous gorge, with a length of 1,386 meters, consisting of 128 steel truss segments. Each individual steel truss segment weighs a staggering 175 tons, which is equivalent to the weight of over 100 family cars. The bridge's 2 main cables are composed of 42,000 high-strength galvanized steel wires, with a total length of 87,000 kilometers, enough to encircle the Earth twice. When it comes to the world of bridges, China's achievements are not just bragging. China's bridge construction technology is truly incredible. Next, we visit the Zhejiang Bridge, a giant bridge that stretches 798 meters across a treacherous mountain valley. While its length may not compare to some of the other super bridges in this video, the Luoji River Bridge is considered an engineering marvel. It holds the record as the world's longest single-tower suspension bridge, distinguishing itself from bridges of similar length with its sole tower, while the remaining structure is supported by cables from a distance. This bridge appears as if it's defying gravity, hanging in midair without visible support. Furthermore, This bridge was constructed in challenging terrain, extending from a 156-meter-tall tower to an anchor point at the far end of a tunnel, all on a steep slope with a 54-degree incline, setting the world record for the steepest tunnel anchor point. Despite its complexity, this bridge plays a crucial role in remote areas, becoming a key component of the 190-kilometer-long U2 expressway that connects Yunnan to major centers like Shanghai. Previously, navigating this valley took over an hour, but the Zhejiang Bridge reduced that time to just 2 minutes, allowing vehicles to travel at speeds of up to 80 kilometers per hour on the 4-lane bridge. This complex megaproject started in 2019 and was completed in 3 years. This bridge has significantly improved the underdeveloped infrastructure in the mountainous regions of China, promoting economic and transportation connections in the surrounding areas. It has played a crucial role in advancing tourism and economic development in the central Yunnan region. Next, we arrive at the Kong-Zhuhai-Macau Bridge, located between the Chinese provinces of Guangdong and Hong Kong and crossing the South China Sea. It holds the record as the world's longest sea-crossing bridge, stretching 55 kilometers and curving like a dragon above the sea. This bridge not only connects the major cities of Hong Kong, Zhuhai, and Macau, but also promotes economic and cultural exchanges. However, its construction has been fraught with controversy and risks. During construction, nearly 20 workers lost their lives, and there was a scandal involving falsification of concrete quality. Additionally, American engineers questioned whether this bridge could withstand the impact of strong winds and huge waves. Although these allegations were officially denied, the safety of this bridge remains a subject of debate. Our journey is not over yet. We're about to show you a bridge that is nothing short of breathtaking. Among these engineering marvels is the Sidu River Bridge, which once held the record for the world's highest bridge before the Beipanjiang Bridge's completion. The Beipanjiang Bridge unquestionably stands as a remarkable engineering feat located in China's Guizhou province. This bridge is renowned for its record-breaking height and innovative design. Soaring to an astounding height of 565 meters above the Beipan River, equivalent to a 200-story skyscraper, it proudly holds the title of the world's highest bridge when measured from the deck to the ground. Situated on the border between Guizhou and Yunnan provinces in southern China, the bridge plays a pivotal role in connecting these challenging terrains. The construction of the bridge was an ambitious undertaking, with a substantial price tag of approximately $147 million. When completed in 2016, it officially set a world record for its height, earning recognition from the Guinness World Records in 2018. This cable-stayed bridge features 4 lanes and boasts the world's second longest span of steel truss cable. Its innovative design and engineering solutions were imperative to overcome the rugged terrain and the need to withstand strong winds in the deep valley. The Beipanjiang Bridge has had a profound impact on transportation in the region, significantly reducing travel times between previously inaccessible areas. For example, it transformed the journey between Yunnan's Zhenli City and Guizhou's Chuxi-Cheng County from a 5-hour ordeal into a mere 1-hour commute. The first bridge of the Beipan River is not only a vital transportation route, but also a captivating scenic attraction. Standing on the bridge, you can overlook the rushing waters of the Beipan River, feel the gentle breeze caused by its turbulent currents, and experience the power of nature. The bridge's unique design gives you a sensation of floating above the river as if strolling through the clouds. With its distinctive design and robust structure, this bridge has created opportunities for human success and prosperity, allowing people to deeply appreciate the harmonious coexistence of humanity and nature in this exquisite and magnificent engineering marvel. Furthermore, the bridge has spurred economic growth by increasing accessibility and attracting tourists to the area. It has enhanced regional integration, enabling people to move more freely. China is renowned for its extensive portfolio of towering bridges, with the Beipanjiang Bridge being a prime example. China leads the world in bridge construction and engineering, boasting several of the world's highest bridges. While the Beipanjiang Bridge currently holds the title of the world's highest, future projects may surpass it. Nevertheless, China's unwavering commitment to infrastructure development ensures its continued leadership in the construction of tall bridges. The Beipanjiang Bridge stands as a testament to China's engineering prowess and dedication to infrastructure development. Its completion has significantly improved transportation and connectivity in southern China, solidifying its status as an iconic symbol of innovative engineering. Height of the world's 20 mega bridges that exceed 300 meters from deck to water, all are in China. So it's not likely that the Beipanjiang Bridge will lose its title as the highest bridge anytime soon, and if it did, it would probably lose it to another. Chinese engineers' creation of the bridge construction not only made commuting easier, but broke some records. Themselves look good, they also created one of the coolest and most breathtaking man-made structures in the world that seemed to blend perfectly with its surroundings. Worth it, the Beipanjiang Bridge might be the highest in the world, but it's nowhere near the most expensive. The title belongs to Hong Kong-Zhuhai-Macau Bridge, which costs $20 billion. The Hong Kong-Zhuhai-Macau Bridge is a milestone in the history of Chinese engineering construction, boasting the longest span, the highest investment, and the most challenging construction complexity in the country's history. The total length of the bridge and tunnel system is 55 kilometers, designed for a speed of 100 kilometers per hour, with a total project investment of 126.9 billion yuan. Its completion marked another significant achievement in China's bridge-building history, earning it the distinction of being one of the 7 wonders of the modern world. The main structure of the bridge is approximately 29.6 kilometers in length, consisting of a combination of bridges, artificial islands, and tunnels. It comprises a 5.3-kilometer tunnel and a 22.9-kilometer steel structure bridge. 2 artificial islands are connected by underwater immersed tube tunnels, and these islands are further linked to the mainland by bridges. The main bridge alone required a staggering 420,000 tons of steel, equivalent to the weight of 60 Eiffel Towers. The entire construction of the bridge followed a modular approach, where all components, regardless of size, including the towering bridge piers, bridge decks, and 100-meter-high bridge towers, were manufactured as complete units in onshore factories and then transported to the sea for assembly, akin to assembling building blocks. This method ensured precision in construction and minimized the environmental impact of the project. The Hong Kong-Zhuhai-Macau Bridge is not merely a bridge, but a testament to human courage and ingenuity. It bears witness to technological breakthroughs and the miracle of human cooperation. Whether you journey across the bridge towards the future or take a leisurely stroll upon it, this bridge will forever stand as an eternal symbol connecting humanity with nature. In the years to come, as you walk upon the Hong Kong-Zhuhai-Macau Bridge once more, you may reminisce about its construction journey and the profound human wisdom and courage it embodies. Regardless of where you are, this bridge will forever link your heart with the magnificent scenery, leaving an indelible mark of beauty. Next, let's take a look at another epic bridge in China, the Yachi Bridge. This bridge boasts a deck height of 434 meters, ranking 5th on the list of the world's tallest bridges. It is also the world's largest cross-border steel truss cable-stayed bridge, constructed with intersecting red steel materials. The main span between the towers reaches 800 meters, making it the world's longest mountainous cable-stayed bridge, reducing the travel time from Guiyang to Tianxi from 2 hours to just 50 minutes. The Banan River Bridge is the world's first kilometer-class cross-border mountain canyon suspension bridge, with a main span of 1,088 meters. Its completion has shortened the travel time from Huangguoshu Waterfall to Guanlin County from 30 minutes to just 5 minutes. The Hezhang Special Bridge, with its towering 195-meter pier number 11, holds the record for the world's tallest concrete continuous steel truss bridge pier. However, among all the bridges in China, the true champion of bridge structure height is the Pingtan Special Bridge, with its central tower reaching a height of 332 meters, setting a new world record for cable-stayed bridge tower height. This bridge opened to traffic in December 2019, reducing the travel time from Pingtan to Luodian from 2.5 hours to just 1 hour, making it a vital transportation route in Guizhou. The Hangzhou Bay Cross-Sea Bridge, a colossal project spanning 36 kilometers, connects Ningbo and Shanghai, significantly reducing travel distances and providing convenience to millions of people. The sheer scale of this bridge is astonishing. It shortens the journey between Ningbo and Shanghai from 400 kilometers to 280 kilometers and reduces travel time from 4 hours to 2.5 hours with a 6-lane, two-way designs, boasting one of the world's highest travel speeds. The Hangzhou Bay Cross-Sea Bridge is one of China's most important bridges, not only transforming regional transportation but also driving economic growth. It is a masterpiece of Chinese bridge engineering and a testament to technology and innovation. Finally, let's take a look at one of China's most famous sea-crossing bridges, the Bohai Bay Bridge. This bridge is one of the world's longest sea-crossing bridges, spanning 36.48 kilometers and connecting China's Liaoning Province and Shandong Province. It serves as a crucial transportation hub in northern China, significantly reducing distances between coastal cities and enhancing regional economic connectivity. This bridge presents not only technical challenges but also the need to withstand harsh weather conditions, including ice, freezing temperatures, and strong winds. The construction of the Bohai Bay Cross-Sea Bridge signifies China's remarkable achievements in bridge engineering, setting an example for the rest of the world and emphasizing the importance of safety and transparency in large-scale projects. In summary, China's bridge engineering is among the most awe-inspiring and breathtaking in the world. These bridges have not only transformed transportation and economic landscapes within China, but have also showcased China's formidable strength in engineering technology and innovation. These bridges are not just feats of transportation engineering, but also symbols of the Chinese people's hard work and spirit of innovation. China's bridge construction offers valuable lessons to the international community and inspires other nations to strive for excellence in infrastructure development. The Shantou Bay Undersea Tunnel is a crucial control project of the Shanshan Railway, with a designed total length of 9,781 meters, featuring a single-tube double-line tunnel. As a subsea high-speed rail tunnel, it is designed to reach an astonishing speed of 350 kilometers per hour. Not only is this China's first subsea high-speed rail tunnel, but it is also the world's first. It is also an undersea high-speed rail tunnel in China constructed using large-diameter tunnel boring machines. The construction of the Shantou Bay Undersea Tunnel is currently underway, officially starting on March 10, 2020. The 9.8-kilometer section is divided into sea and land segments, with the sea segment spanning 3 kilometers and the maximum burial depth reaching 100 meters. Being the world's first subsea high-speed rail tunnel with a depth exceeding 100 meters, its construction difficulty is unimaginable. The underwater tunnels are now quite common globally. Worldwide, there are more than 20 existing underwater tunnel examples, include the 50.5-kilometer Channel Tunnel between England and France, the 23.3-kilometer Seikan Tunnel in Japan, and the 6.7-kilometer underwater tunnel of the Hong Kong-Zhuhai-Macau Bridge. They are mainly distributed in countries and regions such as China, the United States, Japan, and Western Europe. However, only countries with strong engineering capabilities have sufficient funds and advanced technology to construct underwater tunnels. The construction of underwater tunnels is not a simple engineering project. It involves various construction methods, including the drilling and blasting method, which involves inserting explosives into boreholes for blasting, the shield tunneling method and the tunnel boring machine method, which are applicable to soft and hard rock respectively, and the immersed tube method, which involves prefabricating tunnel sections and sinking them to the seabed. The construction process should adopt different methods according to different topography and geology. Apart from the basic tunnel construction, the Shantou Bay Undersea Tunnel faces its greatest challenge in its geographical location. Located in an active seismic zone, the tunnel crosses 17 fault zones, making the construction highly risky. Construction at depths of over 100 meters underwater presents complex geological challenges. The tunnel also traverses Xiao Bay, where strong winds, high waves, and unfavorable construction factors converge. Most of the tunnel is in a high water pressure risk zone, with the maximum water pressure reaching 1 megapascal. Under such water pressure, unforeseeable consequences could occur in the event of an accident. Therefore, the tunnel's structure must be capable of withstanding high water pressure penetration. Moreover, the marine segment not only faces high water pressure but also highly corrosive seawater, posing a severe test for any construction materials. Any technical issues could lead to unforeseeable risks. Additionally, the use of explosives for underwater blasting is not feasible in large rock areas. Many challenges press down on the construction team like a mountain. Furthermore, laying immersed tubes is not suitable for areas with strong currents, and damage to underwater rocks during excavation poses significant obstacles. It's no wonder Western engineers believe this to be an impossible undersea tunnel project. Why is the construction of the Xiao Bay Tunnel significant for China? This tunnel is the world's first high-speed railway deep-sea tunnel to exceed 100 meters in depth. Its depth surpasses the limit achievable by immersed tube tunnel construction technology, so China must use tunnel boring machines or traditional explosive excavation methods to complete the tunnel excavation. For this purpose, China manufactured a tunnel boring machine specifically for this project. This means that China now can excavate high-speed rail tunnels in deep seas. The tunnel boring machine, measuring 130 meters in total length and weighing 4,600 tons, with a cutter head diameter exceeding 15 meters and a cutter head weight of 570 tons, plays an indispensable role in propelling the entire project forward when operating at the seabed. With a cutter head equivalent to the height of a 5-story building, the construction efficiency and operational capacity are highly effective. 2 tunnel boring machines are advancing in the east and west lines of the seabed, and during excavation, they do not disturb the original structure of the seabed, nor do they pose a danger to construction personnel. In case of fault leakage during construction, the well-designed mechanics automatically block the tunnel using the piston principle, providing valuable time for the safe evacuation of construction personnel and safeguarding against potential hazards for continuing operations. Under the immense pressure of seawater, minor seepage may occasionally occur during construction. If not addressed promptly, these minor leaks could lead to significant seawater ingress problems. Hence, the challenges faced are diverse, requiring solutions to overcome and resolve various issues. During construction, targeted solutions are employed based on the diverse geological conditions detected by advanced equipment, addressing the varying difficulty of rock layers beneath the seabed. China's tunnel boring machines play a vital role in maintaining stability during excavation. They can transport crushed stones and sediments in the rear, improving efficiency and reducing the workload for underwater operation personnel, greatly ensuring the safety of the construction team and making the progress of the entire construction smoother and more efficient. As the Xiao Bay Tunnel is not only the world's first subsea high-speed rail tunnel but also the deepest undersea tunnel globally, its construction difficulty and associated risks are enormous. This is why American engineers consider China's Xiao Bay undersea tunnel one of the most unique and crucial modern tunnels globally. If China completes the construction of the Xiao Bay undersea tunnel, it will signify that China has mastered the capability of building cross-sea tunnels at depths exceeding 100 meters. Facing challenges such as ventilation and smoke exhaust difficulties, long construction periods, and extended evacuation and rescue times, the design team innovatively proposed a solution by setting up a service tunnel between the 2 main tunnels. The service tunnel serves as an emergency evacuation route during emergencies and a new air system for the main tunnels in normal situations, controlling the concentration of pollutants and solving the tunnel ventilation problem. This implies that China can build super tunnels capable of crossing large straits, similar to the Channel Tunnel. The construction of the Xiao Bay Undersea Tunnel marks a new milestone for China in undersea tunnel design and construction capabilities. This project is not only a feat in China's construction history but also a milestone in the global tunnel construction field. We will closely monitor the progress of this mega project and extend our profound respect to the courage and innovative spirit of Chinese engineers. The Biheat Dam, a name that has been resounding in recent years, is not only a milestone in China's hydroelectric engineering but also a marvel in the history of global hydropower construction. Its maximum height of 289 meters makes it as tall as a 100-story skyscraper, yet the narrowest at its crest is only 14 meters wide. Despite the extremely slim body, this dam is able to withstand 16.5 million tons of thrust, which is enough to send more than 15,000 Long March 5 rockets to the sky. How is this possible? Perhaps a change in perspective is all we need to know the answer. Looking from above, the Biheat Dam adopts an arch structure, commonly known as arch dam. This structure can transfer the thrust of the water flow to the mountainous sides. With mountains sharing the load, arch dams do not need to be as massive as gravity dams to remain stable. As a statically indeterminate structure, arch dams exhibit extremely high levels of safety that their overload capacity can be up to more than 10 times the design load. The Biheat Dam, located in the lower reaches of the Jinsha River, it is the world's largest under-construction hydropower project with the highest technical difficulty. Its completion will have profound effects on China's energy structure, Yangtze River flood control, and navigation. However, today we won't discuss these high-level topics. Instead, let's talk about the awe-inspiring process of pouring concrete. The pouring process of the Biheat Dam is an engineering marvel. Just imagine, to build this dam, the total amount of concrete required is enough to construct 25 Shanghai World Financial Centers, a scale that is truly astounding. The pouring method is even more jaw-dropping, with 7 huge cable cranes working in concert, lifting containers filled with 30 tons of concrete, and precisely pouring them across the hundreds of meters of the gorge. This not only tests the excellence of the technology but also showcases the wisdom and courage of the engineers. To ensure the integrity of the dam structure, engineers decided to use a one-time pouring method, which meant that for 1,500 days, workers had to work day and night without stopping. To meet the dam's demand for stone materials, engineers mined the rock using explosives equivalent to the power of a light atomic bomb. Up to 200 dump trucks shuttle back and forth on the construction site every day, continuously delivering these stone materials to the stone processing plant. However, during the concrete pouring process, preventing the temperature rise of the dam due to hydration heat and thus preventing cracks became an urgent problem to solve. Chinese engineers demonstrated their innovative spirit by using a type of low-heat cement and strictly selecting stones, greatly enhancing the anti-cracking performance of the concrete. During the mixing process, engineers also added crushed ice to ensure that the concrete could maintain a low temperature of 6 degrees Celsius. Moreover, vehicles responsible for transporting concrete were all equipped with thermal insulation layers to ensure that the temperature of the concrete could be controlled at 12 degrees Celsius when it arrived at the pouring site. To better control the temperature of the dam, engineers divided the dam into sections for pouring and installed temperature sensors, with on-site workers continuously measuring the temperature of each area and uploading the measurement data to the central control system in real time. This control system acts like the nervous system of the dam, responsible for collecting and analyzing various information, including excavation, grouting, concrete pouring, etc. Once any abnormal temperature is detected in a construction area, the central control system will immediately activate the embedded water pipes for automatic cooling, ensuring that the pouring work of the dam can proceed smoothly. At the other end of the deep dam construction, we see Chinese engineers working on a spectacular project, excavating massive cavern groups to install the world's largest generator units. Faced with the challenge of embedding 16 huge million-kilowatt level generator units into an unstable mountain, they have shown remarkable professionalism and wisdom. Engineers first created a massive space on both sides of the mountain, measuring 438 meters long, 34 meters wide, and 89 meters high, a scale large enough to accommodate an aircraft carrier. The amount of sand and gravel excavated is enough to fill 2 West Lakes in Hangzhou. However, excavating such a huge space in the mountains with 2 fault zones and ensuring its stability is undoubtedly a daunting task. To ensure safety, engineers decided to pre-grout the mountain before excavation, as if using glue to bond loose mountain materials into a strong hole. At the same time, they installed more than 4,000 sets of detectors on the front and back mountains, which act as sensitive sentinels, monitoring any slight changes in the mountain at all times. Once an anomaly is detected, the Safety Monitoring Center immediately issues a warning. With safety ensured, engineers began excavation of the caverns. They cleverly divided the excavation of the caverns into 10 layers, excavating layer by layer from top to bottom, and grouting the rock walls with anchors after each layer was excavated. This way, the constructed caverns are like a fortress, impregnable. When they reached the 4th layer, according to the design requirements, a huge gantry crane needed to be installed. This gantry crane's role is to facilitate the installation of the water turbine generator units that would follow. The water turbine generator unit consists of a water turbine and a generator. Its working principle is to draw water from the dam's 200-meter high intake hole, guide it through the huge pipes on both sides of the dam into the spiral-shaped volute, drive the water turbine to rotate, convert the impact force of the water into mechanical energy, and then drive the generator to generate electricity. To withstand the tremendous water pressure, the volute is made of special steel. The rotation of the 1 million kilowatt generator requires a huge rotor, the manufacturing of which is considered the most difficult in the world. This 350-ton water turbine is the core component of the Biheat Dam generator unit. According to safety standards, the dynamic balance of the water turbine is extremely strict, with deviations per kilogram not exceeding 1.5 grams per millimeter. Despite the enormous manufacturing difficulty, Chinese engineers did not back down. They spent a full 5 years to finally produce the world's largest rotor. The rotor is welded together with an upper crown, a lower ring, and 15 blades weighing 11 tons each, requiring the use of tens of tons of welding wire. Moreover, the welding process requires heating the rotor to 120 degrees Celsius before welding can begin, which is undoubtedly a huge challenge for the welders. After welding, the rotor undergoes a series of rigorous tests to ensure its performance reaches optimal condition. Afterwards, it will be sent to the cavern of the dam for installation. Inside the cavern, a gantry crane capable of lifting 1,300 tons will play a crucial role. It will lift the rotor steadily and install it inside the water turbine generator. After the water turbine is installed, the next step is to install the generator rotor, which has a diameter of 16.2 meters, a height of 4 meters, and a weight of 2,100 tons. These installation works require extremely high precision and rigorous operating procedures to ensure the safe and stable operation of the generator unit. When it comes to the gantry crane that can only lift 1,300 tons, you might have some doubts about how it could handle lifting this massive 2,100-ton object. But engineers' ingenuity always surpasses our imagination. They cleverly combined 2 gantry cranes to form a powerful force. What's even more surprising is that they decided to let a female operator control this combined crane. Such an arrangement may confuse many people. Why choose a woman to operate such a large lifting equipment? Is it because women have unique advantages in certain aspects? Perhaps they are more careful, patient, and able to remain calm and stable in complex operations. Or maybe it's just to break gender barriers and show more people the strength and charm of women in the engineering field. Regardless, this female operator demonstrated amazing skills. She had to lift the 2,100-ton rotor to a height of 6 meters and move it steadily to the installation position over a distance of more than 300 meters. This requires extremely high precision and stability, but she did it, and the entire process took nearly an hour. However, this was just the beginning of the challenge. The distance between the generator stator and rotor was only 5 centimeters, which was a huge test for the crane operator. Any slight mistake could lead to the failure of the entire project. Fortunately, she had 12 years of driving experience, and with her rich experience and close cooperation with ground personnel, successfully installed the rotor in the designated position. It is these Chinese engineers who dare to innovate and challenge themselves, using their wisdom and courage, who have created engineering miracles that amaze the world. They have not only demonstrated the excellent level of Chinese engineering technology but also shown the courage and responsibility of Chinese engineers to the world. China's bridges and dams are the shining jewels of Chinese engineering technology, as well as the crystallization of the wisdom of the Chinese people. They witnessed the brilliant achievements of China's engineering construction and showcased the charm of Chinese engineering technology to the world. In the future, we have every reason to believe that China will continue to create more miracles in the field of bridge and dam construction, satisfying the electricity demands of its staggering 1.4 billion population. 400-ton test box only moves slightly and remains well within the control range. Everyone is very pleased with the result. With the advancement of deep-sea engineering technology, humanity has taken another step in harnessing resources from the oceans. China has become the first country to successfully mine fire ice from beneath the seafloor. Fire ice, also known as combustible ice, is a common name for methane hydrate. It exists as a flammable solid in which methane is trapped in a crystal structure of water. Originally assumed to only exist in the outer reaches of space, it has been found to exist in extraordinary quantities on Earth, below the seabed. It is a trough-type photothermal power plant. Unlike the tower type, this plant collects sunlight heat through curved mirrors. Both systems, however, rely on precise solar tracking. After installation is completed, the mirrors will be aligned to within less than 1 millimeter. This plant will feature 9,120 solar troughs generating 50,000 kilowatts per hour. China's currently installed solar power capacity exceeds 70 million kilowatts, accounting for 1/5 of the world's solar generation capacity. The increasing ways to utilize solar energy will revolutionize China's supply of clean energy. Its rapid development showcases China's genuine determination to transform its energy structure. However, other emission-free energy sources remain untapped. China is one of the nations taking the lead in seeking renewable energy from wind. Giant turbines have become a common sight in various landscapes. While wind energy is often harvested more reliably at sea, the harsh environment presents significant challenges for turbine installation and maintenance. Previously, turbine generators were assembled on land and then transported to their operating sites by semi-submersible vessels for final erection. This process was costly. Today, offshore wind power appears to be the future of wind energy, as breakthroughs in installation technology significantly reduce costs. On the eastern coast of China, a new installation method is being trialed. This newly developed tool can accurately set the blade's angle at a height of nearly 100 meters, aligning it perfectly with the rotor hub. If the machine functions as intended, the cost of offshore wind turbine installation will be significantly reduced. The progress of science and technology drives energy development, resulting in a mixed-source energy policy. On a remote peninsula in eastern China, the world's most advanced nuclear power unit is being prepared for operation. The nuclear reaction generates immense heat, which is used to convert water into high-pressure steam, driving generators to produce electricity. The core of a nuclear power plant is the reactor unit, constructed to the world's highest safety standards. Like the safety door, nearly 1/3 of the plant's components are designed with the ultimate goal of safety in mind. At the business end of things lie this 10-meter deep pool and the adjacent reaction chamber. The pool will eventually be filled with pure desalinated water. The installation and replacement of fuel rods will take place here. This area has seen countless hours of meticulous preparation, ensuring everything runs seamlessly. The last round of inspections is nearing completion. The nuclear fuel, ready in the fuel bin, is securely stored at the highest level of security. Over 100 fuel units, sufficient to power the plant, are ready for use. Below this floor lies a stockpile of the most powerful energy source humanity has harnessed. Its energy density is 2.5 million times that of coal. A mechanical arm delicately handles the nuclear fuel assembly, filled with nuclear fuel. Prior to startup, they were not radioactive. For 4 hours each day, the engineers' operations are rehearsed repeatedly to ensure a flawless startup when the plant goes into full operation. Nuclear plants operate on nuclear fission, releasing energy through splitting atomic particles. While immensely powerful, this process generates hazardous radioactive waste. By contrast, the sun generates energy through nuclear fusion, producing no radioactive waste. On July 5, 2017, Chinese scientists astonished the world's scientific community by achieving a temperature of 50 million degrees, a critical milestone in fusion research. However, no known material on Earth can withstand such extreme temperatures. A magnetic field provides the answer. The coil enters a superconducting state at low temperatures, generating the Earth's strongest magnetic field. Suspended within this field are the materials for a fusion reaction. Nuclear power, though controversial, remains a great hope for an endless, reliable, and clean energy source in its various forms. Natural renewables will also play a crucial role in meeting tomorrow's demands, while ingenious solutions continue to be sought for today's challenges. In the sparsely populated deserts of the West, the search for a better future, where needs are met and waste is eliminated, persists. China is committed to this clean, green future with all its energy. The journey through China's mega projects is one of awe and inspiration, a testament to Chinese ingenuity, innovation, and the relentless pursuit of progress. Each of China's ambitious undertakings stands as a testament to human achievement, underscoring how the fusion of creativity and resolve can lead to extraordinary progress. The Xiao Bay River Bridge, another super bridge constrained by extreme geographical conditions, spans over 2,000 meters, connecting the provinces of Sichuan and Guizhou, with a peak height of approximately 350 meters. Constructing this bridge posed a major challenge due to the limited access to the construction site on the Sichuan side, where cliffs made it impractical for most heavy equipment traditionally employed in bridge construction to reach the area. Thus, engineers decided to build the bridge deck off-site and later transport it in 3 segments to the gorge. They used 158 cables to support the bridge deck, ensuring its proper placement using 3D visualization technology. The construction budget for this bridge was just $147 million, far lower than some of the astonishing super bridges we'll mention shortly. Then there's the Baling River Bridge, a cable-stayed steel box girder bridge located above the Baling River in Guizhou. Completed in 2017, it spans 1,080 meters with a vertical height from the bridge deck to the valley floor of 370 meters, equivalent to 120 stories, making it the world's 8th highest bridge. Next, we visit the Guazhigou Bridge in Xinjiang, which is Xinjiang's first cable-stayed and highest bridge. It is the largest and most important bridge in Xinjiang, as well as China's first road steel truss cable-stayed bridge, considered a miracle of infrastructure construction in Xinjiang. The Guazhigou Bridge spans approximately 700 meters, with the bridge deck height above the valley floor of about 200 meters. The entire main bridge is constructed using steel truss technology, with 17,000 tons of specialized bridge steel and high-strength bolt connections instead of traditional welding. Precision during installation had to be maintained within 2 millimeters, costing about $3.4 million per meter, with a total cost of $2.39 billion. In constructing the Guazhigou Bridge, groundbreaking technologies were applied, such as large-volume concrete temperature control, tower and beam asynchronous construction processes, hydraulic jacking, and self-moving templates, establishing valuable experience in constructing highways in mountainous areas. The Guazhigou Bridge boasts a spectacular and unique design. Its S-shaped structure winds through the valley, surrounded by towering peaks and colorful flowers. Driving across this bridge feels like being in a painting. Finally, we arrive at the Yachi Bridge, a cable-stayed steel box girder bridge located above the Yachi River in Hunan. Completed in 2016, it stretches 1,176 meters with a vertical height from the bridge deck to the valley floor of 336 meters, ranking it as the world's 9th highest bridge, following the Beipanjiang Bridge, the Jinshajiang Bridge, and the Balu River Bridge. The long dragon-like main span resembles a great sword piercing the clouds, and it appears as a rainbow bridge, connecting the picturesque landscapes on both sides of the valley. The two towering 206-meter-tall main towers serve as the guardians of the bridge, especially dazzling at night. The cable length and height of the bridge deck above the ground also reach the world's peak. These accomplishments showcase the unwavering spirit of Chinese engineers and their relentless pursuit of the unknown. The Yachi Bridge goes beyond human imagination, incorporating elements of harmony between people and nature, tradition and modernity. It embodies the courage of Chinese engineers in innovation and conveys respect for nature. It will undoubtedly become a lasting human miracle, inspiring future generations to stay true to their original aspirations and promote a positive cycle of harmonious development with nature. Standing on the observation deck at 200 meters high, you can not only witness the magnificent landscapes but also contemplate the harmonious coexistence of humans and nature. These are the most hair-raising bridges in China that we've shared with you. China's bridge projects are undeniably magnificent spectacles, transforming not only the country's domestic transportation and economic landscape but also showcasing China's extraordinary strength in bridge construction technology and innovation. These bridges are not just transportation facilities. They symbolize the relentless pursuit and innovation of the Chinese people, symbolizing the unyielding spirit of exploration in the face of challenging projects. China's bridge construction not only brings invaluable experience domestically but also inspires other countries to actively catch up with China's leading position in infrastructure development. Chinese engineers continue to break technological barriers by building enormous transportation bridges. These bridges are crucial elements of China's vast road network, enabling efficient and rapid transportation. Now, let's start exploring China's mega projects that have reshaped the country. Beipan River Bridge. The vertical height of the bridge deck above the Beipan River reaches an impressive 565.4 meters. The tips of the towers reach 750 meters above the valley floor, higher than two Eiffel Towers and the Statue of Liberty combined. Currently the world's tallest cable-stayed bridge with a steel truss, it proudly holds the title of the world's highest bridge. In terms of grandeur, it surpasses even the iconic San Francisco Golden Gate Bridge. The 20,000-ton steel bridge deck is the length of 5 Titanics. When China announced its plan to invest 1 billion yuan in the construction of the Beipan River Bridge, American experts predicted it would take China 300 years to complete this monumental project. To everyone's amazement, Chinese engineers defied expectations and completed the colossal undertaking at an unimaginable speed, leaving the once mocking American experts silenced.
Oh God, please, no! No!
In reality, it took only 3 years for China to successfully finish the Beipan River Bridge. One can only wonder how long it might have taken if the project were undertaken by the United States. Feel free to share your thoughts in the comments. The rugged terrain and extremely poor transportation conditions in the Guizhou region had a profound negative impact on the local population's economic development. Therefore, in 2013, China decided to construct a world record-breaking bridge at the intersection of Yunnan and Guizhou provinces to completely transform Guizhou's harsh transportation environment. However, this plan faced mockery from Western bridge expert Smith. With a height of 565 meters, equivalent to 200 floors, surpassing even the tallest U.S. structure, the World Trade Center at 412 meters, foreign media rushed to report on the seemingly impossible project. Smith, after inspecting the Beipanjiang Grand Canyon, asserted that even with American technology, it would take 300 years to complete, suggesting China would need at least 3,000 years. Despite the ridicule, Chinese engineers courageously faced the challenge, determined to make Beipanjiang the world's highest bridge. However, the engineering team was undeterred by external mockery and dedicated themselves wholeheartedly to the construction. situated in a canyon with a main bridge length of 1341 meters. Traditional bridge pier construction in the canyon was impossible. Considering wind risks, the construction team opted for cable-stayed bridge technology. During construction, Chinese engineers innovatively employed longitudinal movement and hanging assembly techniques for the first time, lifting and assembling the 12-meter, approximately 160-ton steel trusses in midair. Precision alignment of 27 mm diameter bolts was essential. Despite the fierce canyon winds, Chinese engineers overcame every challenge, demonstrating their ability to tackle any obstacle. To address challenges like impassable rivers for traditional ship transport of cut-off beams, engineers adopted new methods. Beams were disassembled into smaller pieces, transported to the site by trucks, and assembled like building blocks, accelerating the installation process, shortening the construction period, and reducing damage to the bridge piers. Additionally, for the steel cables lifting the bridge deck, China's engineering team used one of the strongest materials with a compressive strength exceeding 1860 MPa and a dynamic load yield strength reaching 250 MPa. This material greatly ensured the stability of the bridge under strong winds and water vapor erosion, guaranteeing the project's safety. We see the deck of the Banan River Grand Bridge connected to its towers, with steel cables spanning 250 feet, enough to stretch from New York City to Washington, D.C. To construct this unprecedented architectural marvel, Chinese engineers had to tackle numerous challenging engineering feats. The bridge spans the isolated depths of the Guizhou Grand Canyon, making it an epic engineering endeavor. Between two iconic towers, it stretches over a mile-long deck. Supported by 250-foot steel cables, it carries an incredible 22,000 tons of weight. This bridge can arguably be deemed the most colossal bridge structure on this planet. Through this project, China not only showcased its strength, providing effective support for poverty alleviation projects in Guizhou and Yunnan, but also defeated foreign experts who once mocked China. In fact, even the United States, with its arrogant statements about China, couldn't guarantee the completion of the Banan River Bridge. This bridge stands as a milestone in China's infrastructure development, serving as an irreplaceable transportation hub. In 2016, with a cost of 1 billion yuan and a construction time of 3 years, the Banan River Bridge, standing at a height of 565.4 meters, successfully set a new Guinness World Record. China's achievement completely contradicted the initial mockery from the famous American bridge expert Smith, who claimed it would take at least 3,000 years to complete. Located in the central part of the Yunnan-Guizhou Plateau, overcoming steep terrain and complex geology, the Banan River Bridge has shortened the travel time between Yunnan and Guizhou to just 1 hour, bringing new hope to this land and becoming a source of pride in China's bridge construction. The completion of the Banan River Bridge signifies another miracle in the history of global engineering. You see, China has once again demonstrated astonishing speed in engineering construction. The Yanshan Overpass Bridge, an iconic structure in a city in China, was successfully dismantled in just 8 hours. This feat has not only amazed domestic and international spectators but has also sparked discussions online. The bridge, which once connected the two banks of the city, had become inadequate for modern traffic needs due to years of disrepair. The local government decided to demolish and rebuild the overpass bridge to improve urban traffic efficiency. However, the entire demolition process took only 8 hours. Chinese engineers showcased their outstanding technical and organizational capabilities, precise planning, and unparalleled execution, attracting global attention with the renowned China speed. Just 48 hours later, the brand new Yanshan Overpass Bridge stood proudly in the city, as if by magic. Allow me to take you through the complex process of constructing highways in desert areas, exemplified by the recent opening of a new highway in China's Taklamakan Desert. This endeavor began in October 2017 and involved multiple stages, from surveying the challenging terrain to designing a road that can withstand harsh desert conditions, including sandstorms. In a similar vein, The construction of railways in desert regions, like the new South Xinjiang Railway, showcases the importance of land preparation, track laying, and specialized techniques to cope with extreme temperatures and environmental challenges. China's dedication to combating desertification is evident in its use of grass grids and green barriers in construction projects. These measures effectively prevent sand movement and erosion, contributing to the reclamation of desert land. Thanks to these efforts, China has restored over half of its manageable desertified land in the past decade, drastically reducing the desertified area. Moreover, China's commitment to renewable energy is evident in the inauguration of the Al-Kharsa solar power plant, one of the largest in the Middle East. This plant signifies a step toward clean energy adoption and carbon emission reduction in Qatar, highlighting the country's shift away from fossil fuels. China's advancements and achievements in combating desertification are exemplary and have even earned global recognition. Through green initiatives, successful projects, and the utilization of clean energy, China is actively working to address desertification and promote environmental sustainability. Step into the awe-inspiring world of China's remarkable construction capabilities, where monumental achievements redefine the boundaries of possibility. Embark on a journey through the heart of a nation that stands as a testament to innovation, dedication, and the relentless pursuit of progress. With a rich history of rapid growth, China has evolved into the world's second-largest economy, a feat that is inseparable from its sophisticated transport networks that traverse its vast landscape. At the core of this remarkable feat lies the world's largest highway network, a web of roads that carry a staggering 80 million tons of freight daily, crisscrossing the nation with efficiency and precision. The sheer scale of this network is paralleled only by the world's largest high-speed rail system, a testament to China's commitment to connectivity. This intricate rail network links hundreds of cities and enables swift, seamless travel for millions. But the story doesn't end there. China's aerial prowess is equally awe-inspiring, with a sprawling air transport system that boasts a whopping 227 airports. And when it comes to maritime supremacy, 7 out of 10 of the globe's largest ports are nestled along China's coastline, underscoring the nation's strategic maritime importance. This intricate transportation network doesn't just serve as a lifeline for the economy, it's a lifeline for progress itself. The relentless drive for advancement has ensured that night and day, the network evolves both quantitatively and qualitatively, meeting the ceaseless challenge of efficiently moving people and goods across the nation. Yet even in the face of such rich tradition, progress is unyielding. Tackling the towering Chola Mountains, which for centuries acted as a barrier between China's heartland and its Tibetan region, is a project of unparalleled ambition. For 5 years, a Herculean effort has been underway to create the world's longest and highest road tunnel. Once complete, this engineering marvel will obliterate the need for the hazardous dirt road that has been traversed for over half a century. It's a struggle that embodies the nation's spirit, where thousands of workers brave the harshest of environments to carve out a safer, more efficient passage. Their dedication is nearing fruition, with the tunnel set to open in just a month, transforming a perilous journey into a 10-minute drive under the shelter of solid rock. It's a testament to China's relentless pursuit of progress and its capacity to overcome even the most imposing challenges. At the heart of this transformation stands Huang Qi-Ting, an engineer who is poised to become the first to drive through the tunnel. Armed with cutting-edge technology, his car is equipped with a 360-degree laser radar, a continuous image-capturing camera, and a positioning data acquisition system. He captures real-time road information as he navigates the tunnel's interior, contributing to a comprehensive mapping effort that has never before been undertaken. These monumental feats of infrastructure are a testament to China's unparalleled commitment to connectivity, growth, and progress. With over 200 million vehicles coursing through the planet's largest highway network, carrying an astonishing 15 billion passengers and over 33.6 billion tons of cargo annually, China's highways are the lifeblood of its economy. But as China propels itself forward, it faces the challenge of maximizing efficiency and reducing waste. Nearly 40% of China's trucks run empty, leading to higher freight costs and unnecessary energy expenditure. This inefficiency undermines the very purpose of its robust highway system. Chengdu, a crucial transport hub, is taking steps to revolutionize the industry. By employing advanced technology, Chengdu's logistics port is streamlining trucking operations. Trucks are matched with cargo requirements, reducing empty runs and optimizing freight transportation. This digital innovation is not only changing the way goods are moved, but also paving the way for a more energy-efficient future. However, highways aren't the only backbone of China's transport prowess. The Yangtze River, the longest in China, has long played a vital role in its communications. The Three Gorges Dam, a monumental feat of engineering, stands as both a flood control mechanism and a significant energy generator, providing power to 9 provinces and 2 cities. With the dam's completion, the Yangtze River has evolved into the world's busiest inland waterway, allowing ships to navigate its once treacherous waters with ease. As China embraces its role as a global player, its demands for energy are substantial. Vast coal reserves in its arid west must be transported thousands of kilometers to meet the energy needs of its thriving eastern cities. The Shuohuang Railway stands as a testament to this logistical marvel, an artery through which 226 trains run daily, carrying essential coal supplies that fuel the nation's growth. The railway is a feat of engineering brilliance, navigating treacherous terrain and overcoming steep descents to ensure the safe and efficient transport of vital resources. Amidst this vast network of connectivity, the heart of Beijing is witnessing the rise of another marvel, a new super airport. This terminal, a marvel in glass and steel, stands as a testament to China's unrelenting commitment to innovation. With a design that optimizes space and maximizes convenience, passengers will be able to traverse this sprawling hub without ever traveling more than 600 meters to reach their gate. But the marvels don't end with the terminal. Beneath its surface lies an even greater innovation. The integration of a high-speed railway station beneath the airport terminal allows for seamless transfers among multiple modes of transportation. This innovation, fueled by cutting-edge technology, ensures that China's new airport doesn't merely serve as a hub but transforms the way people move within a city. As China reaches for the skies, its ambitions extend beyond its own borders. The C919, China's independently developed large passenger aircraft, is undergoing rigorous testing to ensure it meets the highest international standards. Designed to reduce fuel consumption by 15%, the C919 is not only a symbol of China's growing aerospace capabilities but also a testament to its commitment to sustainability and efficiency. That's right, when it comes to modern bridges in China today, both in terms of quantity and quality, they are at the forefront of the world. However, do you know why China is building so many mega bridges? In the upcoming video, we will take you on a journey to trace the history of bridge construction in China. First, we will begin with the most classic type of bridge. This is an ancient bridge design, where 2 piers support 1 beam, considered a beam bridge. The horizontal distance between the centers of adjacent supports represents the span, reflecting the bridging capacity of a bridge. What you see before you is the first modern bridge independently designed and constructed by China in 1937, the Hangzhou-Qiantang River Bridge. It has a maximum span of approximately 66 meters and adopts the structure of a simply supported beam bridge, supporting a box girder between adjacent piers. Extending the girder to form a multiple tons supporting 1 beam constitutes a continuous beam bridge. Due to the continuous and uninterrupted nature of the girder, it can mutually constrain, providing higher load-bearing capacity and achieving larger bridge spans. For example, the Wuhan Yangtze River Bridge has a maximum span of 128 meters. This design enabled the Chinese to successfully cross the natural barrier of the Yangtze River for the first time. In China at that time, these steel bridges were not only technologically advanced but also expensive, mainly applicable to railway construction. With the introduction of a new bridge construction technology, Chinese engineers could easily span bridges across the Yangtze River. The principle of this technology is quite ingenious. Pre-stressing steel bars are embedded in the concrete, utilizing the shrinkage of the steel bars to balance external forces. This allows the bridge structure to withstand larger loads and support greater spans. This technology is known as pre-stressed concrete technology and is more cost-effective compared to traditional steel-reinforced concrete technology. Therefore, propelled by pre-stressed technology, a large number of highway bridges were constructed by Chinese engineers. Until today, the application of beam bridges has become very extensive, forming standard components that can be manufactured in factories and assembled on site. While there are limitations to single-span lengths, by connecting hundreds or thousands of spans, it's possible to span rivers, lakes, seas, and even reach lengths of up to 165 kilometers, completely surpassing road surfaces, making them the world's longest bridges. However, to further increase spans, beam bridges inevitably need to undergo a technological revolution. The appearance of this bridge is very similar to a beam bridge, but its girder and piers are fixed as a whole, allowing them to jointly resist girder bending. This means that with the support of piers, girders can achieve greater spans or choose a more lightweight bridge deck, which is the rigid frame bridge. However, this type of bridge is very sensitive to thermal expansion and contraction, making it prone to bridge deformation or even collapse. To address this challenge, Chinese engineers designed higher piers for cable-stayed bridges, making them more flexible and reducing the risk of pier deformation. In mountainous and canyon areas, this design with tall piers is particularly suitable. So, a towering bridge soared into the sky. This large bridge is called the Hejiang Mega Bridge, with its piers plunging straight into the valley, reaching an astonishing height of 190 meters, equivalent to more than 60 stories. It is the tallest bridge pier in Asia. However, on the plains, there is no need to construct towering piers. To reduce the height of the bridge while ensuring the flexibility of the piers, a special pier form is required. However, the piers need to be slender, the bridge needs to be stable, and the cost needs to be low. These three factors constrain each other, making cable-stayed bridges with spans exceeding 300 meters rare. The Xiao Bay River Bridge, completed in 2006 with a maximum span of 330 meters, became the world's largest pre-stressed concrete continuous steel truss bridge. But when facing steep cliffs, deep valleys, or the need for traffic clearance under the bridge, a bridge form that can span the entire distance with a single span is required, such as an arch bridge. This arch structure requires both ends to not only lift the bridge upward but also provide powerful horizontal thrust. This thrust firmly resists the deformation of the arch, thereby increasing the arch bridge's spanning ability. For example, the truss arch bridge, pioneered by China, has slender concrete arches, making the bridge more lightweight, with a maximum span of 330 meters. As ordinary concrete arch bridges approach their span limits, more and more innovative arch bridges are emerging. For instance, filling concrete in steel tubes adds an extra protective layer, making it more robust than regular concrete. Additionally, steel tubes can serve as the construction framework, significantly reducing the construction difficulty of arch bridges. With the increase in China's steel production, steel arch bridges are also on the rise. Combined with trusses, steel structures, and other designs, they have created one engineering marvel after another. Nowadays, the arch bridges constructed by Chinese engineers have achieved astonishing spans of over 600 meters. What's more, China also plans to build an extra-large bridge with a span exceeding 1,000 meters shortly. Now, you are looking at the Wufingshan Yangtze River Bridge. Let us marvel together at its grandeur. The main cables of this bridge are made of high-strength steel wires with a diameter of 5.5 millimeters, forming bundles of 127 wires each, and 352 bundles create a design with dual parallel cables. These main cables not only serve as the support for the bridge but also represent a colossal engineering marvel. They bear the weight of steel beams exceeding 70,000 tons, equivalent to 1,000 fully loaded Boeing 747 airplanes. Faced with such an enormous load-bearing capacity, the The flow of traffic on the bridge appears insignificant in the face of this colossal engineering feat. Let's go back to the ongoing construction of the world's longest cross-sea bridge in China, the Shenzhen-Zhongshan Channel. This large-scale project, following the Hong Kong-Zhuhai-Macau Bridge, is another world-shocking cross-sea cluster engineering feat. From the initiation of construction, it has faced one global challenge after another. Here, we will focus on the underwater tunnel formed by 32 sections of bidirectional 8-lane steel shell concrete caissons, and the length of this underwater tunnel is an astounding 6.8 kilometers. Its construction difficulty is considered unparalleled in the world. However, Chinese engineers always find ingenious solutions using their intelligence. The enormous transport ship you see now is the Yihang Jinan 1, an integrated installation ship designed and manufactured by Chinese engineers. The main body of Yihang Jinan 1 adopts a catamaran ship design, integrating functions such as caisson floating, positioning, sinking, and installation. With a length of 190.4 meters, width of 75 meters, and depth of 14.7 meters, it is the world's most advanced underwater tunnel caisson construction vessel with the largest installation capacity, highest precision in sinking, most efficient construction operations, and cutting-edge performance. Now it will depart from Goishan Island, transporting caissons weighing up to 80,000 tons to the construction site of the caisson tunnel 50 kilometers away. This will be an epic construction operation, and the caisson transport and installation ship will carry out mooring, hoisting, positioning, and other tasks. At a depth of over 30 meters underwater, achieving millimeter-level precision docking for the 80,000-ton caisson is as challenging as the docking of crewed spacecraft and the Tiangong space station. The caisson transport and installation ship Yihang Jinan 1 acts like a massive rectangular steel clamp, firmly holding the final section of the caisson and the ultimate joint at the bottom of the ship. Controlled by the intelligent system installed on the ship, the final joint is precisely pushed out, achieving the precise docking of the last caisson with the E24 section on the east side. From this point on, the world's longest and widest steel shell concrete caisson tunnel, the Shenzhen-Zhongshan Channel Underwater Tunnel, is officially connected. The construction of the Shenzhen-Zhongshan Channel Caisson Tunnel embodies the collective wisdom of the Chinese engineering team, showcasing a leap in China's overall industrial technological capabilities. Finally, let's take a moment to reflect on this map of China, which may evoke a unique set of emotions. It's hard to imagine how generation after generation of builders overcame numerous challenges such as topography, geology, hydrology, meteorology, materials, structures, and navigation. Even in economically challenging times, China continued to create new technologies, repeatedly achieving breakthroughs. The nearly 1 million bridges bear witness to the arduous journey China has traveled. Success in bridge construction not only plays a crucial role in domestic development but also has a positive impact on global bridge construction. What comes to mind when you think of American cities? Bustling streets, well-maintained roads? The reality might disappoint you. In fact, most American streets are far from tidy, trash is abundant, and the roads themselves are in a sorry state. Pakistani Prime Minister Imran Khan once openly criticized the condition of New York's roads, describing the experience of driving on them as excessively bumpy.
The Chinese were developing first world infrastructure, and you'll just have to go to China to see the way their infrastructure is. And I'm in New York, and I'm watching the car bumping around here. Okay. That money was wasted.
You know, you do not sound right now like a prime minister from Pakistan.
Contrasting this with major Chinese cities reveals a stark difference. Why hasn't the United States improved its infrastructure? Before discussing this question, let's examine the current state of American infrastructure. From a statistical perspective, the United States has a commendable level of infrastructure. In terms of highways, it boasts a total length of 6.85 million kilometers, over 1 million kilometers more than China, perfectly befitting its status as a global superpower. However, a significant portion of these highways were constructed a century ago, while many others were built between the 1950s and 1980s. Very few new roads have been built. It's not difficult to imagine the poor condition of American highways, with potholes being a common occurrence. Even major cities like New York cannot escape the fate of a bumpy ride, let alone more remote areas that will make you question your life choices. Moving on to the subway system. How terrible is the subway in the United States? Former Secretary of State Hillary Clinton once visited a New York subway station and struggled to enter the turnstile, swiping her card 5 times in front of a crowd. Besides outdated turnstiles, the trains and tracks are equally outdated. Every time a train arrives at a station, it produces a thunderous noise. Listen. The thunderous roar emitted by the US subway when it arrives at the station is like an airplane taking off, and the noise it produces is highly discomforting. Now, let's take a look at China's subway system, and I believe that with this comparison, you'll see just how outdated the subway system in the United States really is. So, with a subway system as outdated as the one in the United States, do you still expect it to excel in other aspects? It's slow, often delayed, and gives people the constant feeling that the train could break down at any moment. Moreover, the subway systems lack various user-friendly designs. Firstly, many subway stations don't have elevators, making it difficult for passengers carrying large luggage or with disabilities to use the subway. Secondly, there are no safety barriers between platforms and tracks, increasing the risk for passengers. In New York alone, there are over 100 safety incidents each year due to these issues. In addition, the New York subway also offers a unique sightseeing experience: trash and rats. You can see these two things almost everywhere in the station, on the tracks, and even inside the train cars. If you don't believe me, watch this short video. As the saying goes, no pain, no gain. Let's take a look at China's subway system. halls are spacious and brightly lit, with smooth and clean floors that reflect people's images clearly. Even a casual photo captures a sense of modernity. However, the New York subway, with its dim lighting, deteriorated walls with peeling paint, and the accumulated dirt seen everywhere on the floors and ceilings, makes it hard to imagine that beneath the glamorous New York City lies such a historically rich side. It's safe to say that New York City has one of the worst subway systems in the world. The poor state of the subway system extends to trains and airports as well. Remember the recent train derailment in Ohio? Well, the U.S. Secretary of Transportation, Pete Buttigieg, wasn't surprised at all. Why? Because there are around 1,000 train derailments in the United States every year, but the one in Ohio received the most attention. The situation is similar for airports and train stations, which are plagued by issues of dirt, outdated facilities, and aging infrastructure. However, these issues aren't the most severe problems in the United States. More severe issues are found in bridges, power grids, and dams. In early 2021, Texas experienced widespread water and power outages due to extreme cold weather. In June of the same year, an apartment collapse in Miami claimed the lives of 94 people. In 2020, 2 dams in Michigan burst. Tragedies caused by aging infrastructure are countless in the United States. In 2017, the American Society of Civil Engineers reported that over 200,000 bridges in the United States were over 50 years old, with an additional 56,000 bridges having structural deficiencies. It is perplexing why the United States, knowing the extent of its outdated and deteriorating infrastructure, has not taken swift action to improve it. Actually, it's not that the United States doesn't want to improve, it's just that they lack the means to do so. This might come as a shock to many. How could the mighty world superpower that spends so much money creating havoc around the globe not have enough funds for infrastructure? But unfortunately, that's the case for the United States. From Obama to Trump, and now Biden, all of them have made efforts to address infrastructure issues. For instance, when Obama took office in 2009, he vowed to have 80% of Americans riding high-speed trains within 25 years. Yet, what has been achieved to date? 14 years have passed, with 2 presidential terms, and high-speed rail is still a distant dream within the United States. The only project that was initiated, the California high-speed rail, turned into a massive failure. It was approved in 2008, construction began in 2015, and in 2019, they announced a significant reduction in the project, cutting the original 826.8-kilometer route down to a mere 190 kilometers, with a travel time of only 2 hours. Is there really a need for a high-speed rail? Apparently, even the California government had doubts, resulting in delays and ultimately a complete failure to complete the project. As for the existing high-speed rail, the Acela Express, it has an average speed of 110 kilometers per hour and a maximum speed of 240 kilometers per hour. It can be considered a long-distance train rather than a high-speed rail system. In stark contrast, China's C500 high-speed trains can reach a maximum speed of 505 kilometers per hour, demonstrating a vast difference. The Acela Express has been in operation since 1993, and after 30 years, it's no wonder it's been left behind by the times. Even Trump couldn't ignore the dire state of infrastructure in the United States. He planned to spend $1.5 trillion to rebuild the country's infrastructure, including roads, dams, bridges, power grids, and more. Unfortunately, the proposal failed, and the first step of the infrastructure plan was abandoned. And what about Biden? As soon as he took office, he introduced the Reconstruction for a Better Future Act, which not only incorporated the infrastructure plan from the Trump era, but also included the field of renewable energy, with a budget of $2 trillion.
In fact, it's the largest American jobs investment since World War II. It will create millions of jobs, good-paying jobs. It will grow the economy, make us more competitive around the world, promote our national security interest, and put us in a position to win the global competition with China in the upcoming years. It's big, yes. It's bold, yes. And we can get it done.
However, like his predecessors, Biden faced a significant challenge. There was no money. Despite the wealth of the United States, where did all the money go? Military spending, scientific research projects, provoking other countries, the list goes on. As for infrastructure and welfare, these initiatives are continuously delayed because they are not considered priority projects in the United States. So Biden came up with a solution: increasing corporate taxes. This didn't sit well with Trump.
Are our leaders? How stupid are these politicians to allow this to happen? How stupid are they?
After working tirelessly for 4 years to reduce corporate taxes from 35% to 21%, he couldn't believe that as soon as he stepped down, Biden planned to raise them to 28%. It felt like a robbery. Moreover, Biden's infrastructure plan was touted as a means to compete with China, but with increased corporate taxes, it's unlikely that anything substantial will be accomplished. Consequently, Biden's bill initially upset entrepreneurs, and some even suggested that whoever uses roads and power grids should foot the bill. The Republican Party, to which Trump belongs, was largely opposed to the bill. On one hand, its implementation would escalate the U.S. fiscal deficit, worsening the country's situation. On the other hand, it simply became a matter of party rivalry, opposing any policy proposed by the opponents. Additionally, some members of Biden's Democratic Party staunchly opposed the Reconstruction for a Better Future Act, fearing it would lead to severe inflation in the United States. While their reasons may sound valid, it's clear that personal interests play a significant role in their opposition. Despite the convoluted process, the infrastructure bill was eventually passed due to popular demand. The only downside was that the bill's budget plummeted to $1.2 trillion. Though it may sound like a substantial amount, when used for infrastructure, it's merely a drop in the bucket. Just take a look at the allocation of funds in the United States, when $650 billion was initially allocated for infrastructure and maintenance. After deducting those costs, the remaining new funds amount to only $550 billion. Out of that, $110 billion is designated for major road and bridge projects, $73 billion for power grid expansion and updates, and so on. Let's not forget the railway construction project. Back in 2008, the budget for the California high-speed rail was $33 billion, and it took 7 years to commence construction after the project's approval. But guess what? By 2018, halfway through the project, only 191 kilometers had been completed, and the cost had skyrocketed to $77.3 billion. And now, a mere $66 billion is allocated for railway projects. Is that enough? We haven't even considered the severe inflation the United States has been facing in recent years, along with rising labor costs. On the other hand, China's Beijing-Shanghai high-speed rail, approximately the same length as the California high-speed rail, started construction in 2008 and opened for traffic in June 2011. In just 3 years, China accomplished what the United States failed to do in over a decade. Moreover, when the California high-speed rail was abandoned in 2019, it was reduced to a mere 191 kilometers, costing a staggering $93.73 million per kilometer. In contrast, China's Beijing-Shanghai high-speed railway had a total investment of 220.9 billion yuan, with a construction cost of approximately 167 million yuan per kilometer. In terms of cost, the United States spent 4 times more than China but failed to complete the project. The gap in infrastructure between China and the United States is vividly apparent. China's infrastructure level is not only reflected in this aspect. For example, in January 2018, the Longyan railway station in Fujian underwent a major renovation in just one night without disrupting travel the next day. In 2017, More than 200 excavators in Nanshan worked together to dismantle the Long Langmiao overpass, a 589-meter-long structure, in just 8 hours. It was an extraordinary feat. Let's not forget the Leishanshan Hospital in Wuhan, built in 12 days, or the even faster construction of Huashanshan Hospital in 10 days. And who can forget the 30,000-ton passenger station that was moved 288 meters without being demolished, a remarkable display of engineering prowess. Out of the 10 tallest buildings in the world, China claims 6. Particularly in recent years, China has made extensive efforts in infrastructure construction, spending over 10 trillion yuan each year. It's both wealthy and efficient, earning China the title of an infrastructure maniac. Even Elon Musk marvels at how China's infrastructure progress is over 100 times faster than that of the United States. Can you believe that more than 100 years ago, the United States was once the pioneer of infrastructure development? In 1840, while China was suffering from foreign aggression, the United States had already built 2,818 miles of railways, making it the country with the longest railway mileage at the time. By 1910, American railways spanned 410,000 kilometers, accounting for half of the world's total. And what about China's railway mileage today? It stands at a mere 155,000 kilometers, highlighting the disparity in infrastructure between the two countries. The Empire State Building, completed in 1931, took 410 days to construct and stood as the world's tallest building for 41 years. It was considered one of the 7 engineering wonders of the modern world. The Hoover Dam and Golden Gate Bridge, both iconic American engineering marvels, were also built before World War II. In addition, roads, power grids, subways, all were completed in the 1960s and 1970s, decades ahead of China. However, with such a remarkable history of infrastructure development, why has the United States fallen behind? Let's not forget how the American railroads were built. In 1849, a large number of Chinese laborers went to the United States to construct the Pacific Railway. The working conditions for the Chinese laborers were horrendous. Wage deductions were the least of their worries. The worst part was that they were treated as less than human. Regardless of freezing temperatures or scorching heat of 50 degrees, white overseers would drive them to work. Refuse to work? Well, they'd whip and starve you until you complied. Just during the construction of the Pacific Railway, thousands of Chinese laborers lost their lives. The Chinese workers faced immense hardships, but the Native Americans suffered even more. They built railways, dug canals, and constructed cities wherever roads were needed, nearly driving the indigenous population to extinction. It's clear to see now, isn't it? The title of American infrastructure maniac was not earned by white people themselves, it was the result of enslaving other nations. Now, with no one else left to enslave, they can only rely on themselves. But with high wages and excellent benefits in the United States, who would dare to complain? No work on scorching hot days, off on rainy days, and staying home during windy and snowy weather, plus the 8-hour work system on various holidays. How can infrastructure costs not skyrocket? After all, even if workers don't work, wages cannot be reduced. Attempt to pay less, and the unions will make sure to give you trouble. The high cost of infrastructure, coupled with a lack of willingness to invest, compounds the problem. Back in the day, when the United States had an abundance of land, they could afford to give it away to attract investors. But what about now? 58% of the land is privately owned. How can the United States foot the bill? Even to undertake infrastructure construction and use other people's land, they have to pay for land acquisition. Therefore, the United States' dream of competing with China in infrastructure is simply a fantasy. Even if the infrastructure bill is passed, the future remains bleak. Just take the California high-speed rail project as an example. Clearly, it's a shining illustration of the challenges the United States faces. So what do you think about the fact that the United States can't compete with China in terms of infrastructure? We head to the Longjiang Suspension Bridge in Yunnan, China. This bridge connects the cities of Baoshan and Tingchong and stands at a height of 300 meters, equivalent to the height of a 100-story building. The bridge is located in a seismic zone with a history of strong earthquakes. To ensure the bridge's safety, engineers employed advanced seismic technologies and materials, but you can imagine the feeling of experiencing an earthquake on a bridge 300 meters high. It's bound to be hair-raising. Yet, that's just the beginning. We'll soon see even higher and more dangerous bridges. It is the Beipanjiang Bridge. The bridge has a total length of 1,314.4 meters and is part of the Hangzhou Expressway. It starts from Duge Town in Yunnan and reaches Laolong Village in Guizhou. In between, it spans the Nizhu River Grand Canyon, earning it the name Nizhu River Bridge. The completion of the Beipanjiang Bridge marked the full opening of the 3,404-kilometer-long Hangzhou Expressway. What sets it apart is its height above the river, standing at a staggering 565.4 meters, equivalent to the height of a 200-story building. In the world of bridges, it is considered the tallest. If a person were to fall from the bridge, it would take over 10 seconds to reach the ground, a terrifying prospect for anyone. Beipanjiang Bridge claimed the top spot in the world's highest bridge competition, setting a Guinness World Record in 2018. However, China didn't undertake the construction of this bridge for awards. It was done to facilitate local travel. The distance between Duge Town and Puli Township may be relatively short, but the challenging, mountainous terrain and absence of a direct road turn it into a 4-hour journey, requiring travelers to traverse 3 mountain ridges and cover around 40 kilometers of mountain roads. However, with the completion of the bridge, the journey was reduced to just 1 or 2 minutes, greatly enhancing the convenience of travel between the two sides and promoting economic development in the region. Why was the bridge constructed at such a high relative altitude of 565.4 meters? The area where Beipanjiang Bridge is located, within the Yungui Plateau, features a karst landscape formed by the dissolution and deposition of soluble rock by underground and surface water. The fragile mountain structure in this region doesn't lend itself well to bridge construction. After a year of surveying and exploration, Chinese engineers determined that 565.4 meters was the optimal height to avoid caves and fissures. When planning the Beipanjiang Bridge, American engineers claimed that it would take China 3,000 years to complete. However, the bridge's construction began in 2013, and it was operational by the end of 2016, taking only 4 years. The bridge is made up of a pair of massive concrete towers. The tallest is 269 meters high. The 20,000-ton steel bridge deck is the length of 5 Titanic. One World Trade Center in New York could fit underneath. The deck is attached to the towers with 400 kilometers of cables, enough to stretch from London to Amsterdam. The Beipanjiang Bridge stretches 1.3 kilometers across the ravine. The tips of the towers reach 750 meters above the valley floor, higher than 2 Eiffel Towers and the Statue of Liberty combined. During the construction of the Beipanjiang Bridge, Chinese engineers encountered numerous incredible difficulties and challenges. The first was the terrain, as the Beipanjiang Canyon had steep terrain and complex geology, making construction extremely difficult. The second challenge was extreme weather. Constructing a bridge in the southwestern region entailed addressing recurrent geological hazards, in addition to contending with severe weather conditions such as strong winds, dense fog, heavy rain, and freezing temperatures, which placed high demands on the bridge's ability to withstand these conditions. The primary question was what type of bridge to construct. Conventional beam bridges, arch bridges, and concrete cable-stayed bridges couldn't span the 670 meters of the Beipanjiang Canyon. Designers had to choose between steel truss bridges, cable-stayed bridges, and steel truss girder suspension bridges. Due to the fragile cliff slopes of the karst region, which couldn't support the load of a suspension bridge, a cable-stayed bridge was ultimately chosen. To manage economic costs and environmental impacts, Chinese engineers designed the Beipanjiang Bridge as a double-tower cable-stayed bridge with a span of 720 meters. After the promising blueprint was created, the real challenges began. The U-shaped Nizhu River Canyon extended over 500 meters deep, making it impossible to transport the bridge sections, each weighing hundreds of tons, to the construction site. As a solution, designers divided each section into smaller units of around 10 tons and used reassembling and cantilever launching techniques. Furthermore, Chinese engineers had to use 224 strands of 15.2 millimeter diameter cables to support the weight of the entire bridge, a seemingly impossible task that was achieved with galvanized steel wire boasting a tensile strength of up to 1770 megapascals. To counteract corrosion of the cable stays from extreme weather, Chinese engineers added layers of galvanization, grease, and HDPE both inside and outside the stays, significantly extending their lifespan. On September 10, 2016, after overcoming numerous challenges, the Beipanjiang Bridge was officially completed. Would you dare to drive on this bridge? If you find this terrifying, stay tuned for even more spine-chilling bridges to come. The Three Gorges Dam. It's a concrete gravity dam located in the middle reaches of the Yangtze River, not only the world's largest hydraulic engineering project, but also the world's largest hydroelectric power station. It spans the majestic Yangtze River, creating a reservoir that covers more than 600 kilometers, exceeding the land area of the entire country of Singapore. Its scale is so vast that it has even slightly altered the Earth's rotation. It's an inspiring endeavor, but also a challenging one. While it provides power to hundreds of millions, it has also faced criticism due to concerns about potential collapse. But what's the truth behind it? Is the dam really at risk? Let's explore the story of this mega project together. The construction of the Three Gorges Dam was an enormous challenge. It took nearly 80 years, from the initial planning in 1932 to the official commencement in 1994, and finally, comprehensive completion in 2006. Throughout this process, engineers had to overcome various difficulties and risks, such as diverting the flow of the upper reaches of the Yangtze River while ensuring sufficient water continues to flow downstream. They also had to build such a massive project on a major river, using over 16 million cubic meters of concrete, and do so in a seismically active area, requiring considerations of geological stability and earthquake resistance. The construction of the Three Gorges Dam is a magnificent feat of the Chinese people and a model in the world of hydraulic engineering. While the Three Gorges Dam has brought significant benefits, it also faces challenges and problems. The most prominent issue is the resettlement of people from the reservoir area. With thousands of cities, towns, and villages submerged by the reservoir, around 1.4 million people were forced to relocate. Despite government compensation and assistance, many of these resettled individuals still face difficulties and dissatisfaction related to housing, employment, education, and healthcare. Another crucial issue is the environmental impact. Reservoir impoundment has led to bank collapses, geological disasters, water pollution, and a reduction in biodiversity. Especially rare species like the Chinese river dolphin and the Chinese paddlefish have become extinct or are on the brink of extinction. There is also a serious issue of collapse risk. If the dam were to suffer damage or breach, it would have catastrophic consequences, endangering the lives and property of hundreds of millions downstream. Hence, the Three Gorges Dam requires constant scientific assessment, monitoring, and maintenance to ensure its structural integrity and operational safety. One of the primary functions of the Three Gorges Dam is power generation. It has 32 units with 700,000 kilowatt and 2 units with 500,000 kilowatt hydroelectric generators, giving it a total installed capacity of 22.5 million kilowatts, with an annual power output exceeding 100 billion kilowatt hours. This is equivalent to saving 31 million tons of standard coal each year and reducing carbon dioxide emissions by 86 million tons. The Three Gorges Dam is the world's largest power station by capacity, far surpassing any other hydroelectric or nuclear power station. For comparison, the largest U.S. hydroelectric station, the Hoover Dam, is only a tenth of the capacity of the Three Gorges Dam.
Oh, God, please, no! No!
The Three Gorges hydropower station supplies stable clean energy to the Yangtze River Basin and the eastern coastal regions, underpinning China's economic and social development. Another vital function of the Three Gorges Dam is flood control. The Yangtze River is one of China's longest and most important rivers, but is prone to flooding. In the 1930s and 1950s, two massive floods caused millions of deaths and extensive property damage. To protect cities and rural areas along the Yangtze River from flooding, the Chinese government decided to build the Three Gorges Dam in the middle reaches of the river. The dam can store 39.3 billion cubic meters of floodwater, significantly reducing the flood risk for the lower reaches of the Yangtze. It is estimated that the Three Gorges Dam can reduce a once-in-a-century flood to an event that occurs once every 1,000 years. The dam provides security for the Yangtze River Basin and downstream cities, reducing casualties and economic losses. The Three Gorges Dam also serves as a vital transportation link. The Yangtze River is one of China's most important inland waterways, but navigation has been restricted due to meandering river channels, water level fluctuations, and treacherous rapids and shoals. The Three Gorges Dam has addressed these challenges by constructing ship locks and a ship lift, facilitating vessel passage between the upper and lower reaches of the Yangtze. The ship locks at the Three Gorges Dam are the largest in the world and can accommodate either one 10,000-ton cargo vessel or 6 1,000-ton cargo vessels simultaneously. The dam's ship lift is the most advanced in the world, capable of lifting vessels weighing up to 3,000 tons from the downstream to the upstream or vice versa in just 40 minutes. The Three Gorges Dam provides efficient and convenient waterway transportation for the Yangtze River Basin and countries along the Belt and Road, promoting trade and cooperation. In conclusion, the Three Gorges Dam is a super project with both pros and cons, achievements and challenges. It embodies the spirit of the Chinese people who fear no difficulties, dare to innovate and strive for excellence, as well as the complex relationship between China's socio-economic development and environmental protection. The Three Gorges Dam is an engineering marvel that deserves our respect, study, and reflection. While the dam undergoes regular inspections, there have been satellite images circulating online that appear to show slight deformations in the shape of the Three Gorges Dam. Still, the Chinese government quickly dismissed these rumors, attributing these distorted images to algorithm errors in Google Maps. They explain that while some deformation may indeed exist, it is not as severe as depicted in the images. So, the claims that have circulated in recent years, suggesting that the Three Gorges Dam has deformed and is at imminent risk of failure, are unfounded. These claims aim to undermine the safety and reliability of the Three Gorges project, create panic, and sow discord. Firstly, the design and construction of the Three Gorges Dam have undergone rigorous scientific scrutiny and technical testing, meeting international standards and regulations for hydraulic engineering. The dam utilizes a concrete gravity structure, ensuring strong stability and earthquake resistance. Advanced construction technologies and equipment were employed during the dam's construction to guarantee the quality of the concrete and the compactness of the dam body. During operation, the dam is equipped with an extensive safety monitoring system and emergency response plans, continuously monitoring and analyzing various indicators to detect and address any abnormalities in real time. According to officially disclosed data, as of April 2019, all indicators of the dam were within design allowances. Secondly, it's essential to understand that some degree of deformation is normal and does not imply danger. Any hydraulic engineering project will experience deformation due to factors such as water level, temperature, and seismic activity. This deformation is periodic, reversible, and controllable, and it does not affect the structural integrity or operational safety of the dam. The Three Gorges Dam considered these factors during the design phase and has maintained a margin of safety. Monitoring data indicates that the deformation of the Three Gorges Dam is within the elastic range, with no irreversible or excessive deformation. Finally, it's crucial to recognize that the use of photos from platforms like Google Maps as evidence of the Three Gorges Dam's deformation is scientifically unsound and unreliable. These photos are often generated through stitching, compression, and processing and do not accurately reflect the actual situation. Additionally, the photos may have been taken or obtained at different times, angles, and resolutions, making them unsuitable for effective comparison. Even if some changes appear in the photos, these could result from factors like lighting, perspective, and scale, creating visual errors without necessarily representing actual changes. In summary, the controversy surrounding the deformation of the Three Gorges Dam is an unfounded rumor created and spread by some individuals with ulterior motives. We should approach this issue with a scientific and rational mindset and have faith in the safety measures and capabilities of the Three Gorges project. We should view this project with pride and confidence. It is a great achievement for the Chinese people and a model in the world of hydraulic engineering. So, what are your thoughts on the Three Gorges Dam project? Do you believe the dam has truly deformed and is at imminent risk of collapse? We all know that the plank path is a remarkable invention in ancient Chinese transportation history. In order to traverse deep mountain valleys, people ingeniously carved rhombic holes into cliffs isolated by rivers, inserting stone or wooden stakes into these holes. Planks or stones were then horizontally laid, providing walkways. In this video, we'll explore how these thrilling cliffside pathways were created. First, let's talk about the plank path workers in China. They are a group of warriors who bravely construct pedestrian pathways on cliffs, using their hands and wisdom to open up paths for transportation and tourism in mountainous areas. Their working environment is extremely harsh, facing significant risks during the construction process. Yet, the outcomes of their labor are truly astonishing. They are not only miracles of China's infrastructure, but also a source of pride for the Chinese people. Each plank path they build is an engineering marvel. They not only provide convenience for transportation and tourism in mountainous areas, but also add charm to the local scenery. The construction of a plank path is a challenging and arduous task. Workers not only face harsh natural conditions, but also bear enormous safety risks. Without safety protection measures, workers stand on scaffolding near cliffs during plank path construction, risking the danger of falling into the abyss. They walk on toughened glass, facing the risk of severe injury or death if the glass breaks or slips. When constructing steel pipe frameworks, the risk of pipes loosening or breaking poses a threat of piercing or injuring workers. While laying wooden planks or concrete, the possibility of boards or concrete falling could result in self-injury or harm to colleagues. Throughout the construction process, workers must remain vigilant against natural disasters such as landslides, falling rocks, lightning, and more. Along the plank path on the cliffs, workers shuttle back and forth, seldom speaking. They concentrate on their work and the path beneath their feet. Workers are pushing mixed soil on a narrow cement plank path, slightly over 2 meters wide, a sight-inducing anxious perspiration. Due to the unique geographical location, the mountain road can only reach the parking lot at the foot, about 400 meters away from the construction site. To build the plank path, the construction team managed to provide water and electricity without conventional access to such resources. Cement and sand needed for the project were manually transported by workers in buckets suspended on ropes. However, workers on the plank path lack safety guarantees while working on cliffs hundreds of meters high. They have no safety ropes, only rudimentary tools such as wooden boards, hand carts, and rusty scaffolding. During plank path construction, finding a reasonable plank path route based on the terrain and topography is crucial. Workers stand on scaffolding near cliffs without safety protection measures, which is just the first step in road construction. Plank path workers build steel pipe frameworks and lay wooden planks or concrete, forming a stable pedestrian pathway on the cliffs. The construction of plank path requires advanced skills and rich experience, as every terrain and wind direction is different, requiring design and construction based on the actual conditions. Plank path workers usually do not use safety ropes because they would affect their flexibility and efficiency. They rely on their own balance and agility to shuttle in high altitudes. They work from 6 a.m. to 5 p.m. daily, each assigned specific tasks, earning around 300 to 400 yuan per day. The work ethic of plank path workers is admirable. They face difficulties without fear or hesitation, pursue excellence without negligence, shoulder social responsibilities without greed or selfishness. They are a group of people with noble character and lofty ideals. With their sweat and lives, they contribute to China's development and the happiness of its people. They are the plank path workers of China. Now, let's experience another even more thrilling cliffside road. This cliffside road is renowned as one of the world's most treacherous highways, constructed in the 1970s. With a total length of 1,500 meters, height of 5 meters, and width of 4 meters. To ensure visibility for drivers, workers carved out 30 windows of various sizes on the rock face, offering a view through which one can witness the sheer cliffs below. What is truly astonishing is that this road is hailed as the 9th wonder of the world because it was manually chiseled by 13 farmers over 5 years, without the use of any mechanical equipment. During the construction, villagers went to great lengths, breaking 4,000 hammers and consuming 12 tons of steel drills. With sheer determination and bare hands, the entire village carved out this breathtaking passage amidst the mountains. Today, this cliff-hanging road stands as a symbol of Guoliang Village and serves as the primary attraction in the 4A-rated scenic area of Mount Wanxian in China. Finally, let's explore together the houses perched on the cliffs at the foot of the mountain. This place seems like a real-life martial arts world, with every scene breathtaking. Wanxian Valley is located in a remote mountainous area in China, surrounded by magnificent mountains, lush forests, and clear streams. The beauty and tranquility of this place are awe-inspiring as if it were an isolated paradise. However, the most remarkable are those houses on the cliff edges, appearing as a perfect integration of humanity and nature. Constructed by local villagers, these houses employ ancient building techniques and materials. Most of them are wooden structures, harmoniously coexisting with the surrounding environment. Built against the mountains, wooden ladders and paths on the cliffs lead to different residences, each step providing an intimate encounter with nature. Looking out from the windows of these houses, you'll be greeted with picturesque landscapes, mountains, waterfalls, and swirling clouds. creating a sense of being in a fairyland. Wongen Valley is a place that captures the imagination, pushing the harmony between humanity and nature to the extreme. Here is like the beautiful scenes in Hayao Miyazaki's animated films. Do you like such a place? China, a nation of resilience and determination, has always commanded utmost respect. Its hard-working people embody the essence of perseverance and dedication. Despite facing numerous challenges and enduring profound pain, they never cease to strive for greatness. China's indomitable spirit is a testament to their unwavering commitment to excellence. In times of adversity, China's unwavering understanding of humanity shines bright. Their profound philosophical insights encapsulate the essence of compassion, empathy, and unity. China's philosophy of life is a boundless source of wisdom, guiding individuals towards a deeper understanding of the human experience. China, with its rich history and cultural heritage, has left an indelible mark on the world. The achievements of its people and their relentless pursuit of progress inspire admiration and awe. Their unwavering determination to make China the best resonates with the hearts of millions. China's contributions to humanity are truly remarkable. From revolutionary advancements in technology and science to promoting peace and harmony in a rapidly changing world, China has proven to be a guiding light for humankind. The values ingrained in the Chinese culture, such as respect, integrity, and honor, serve as a beacon of inspiration for people around the world. Let us celebrate China, a nation that continues to grow and prosper against all odds. Let us cherish their commitment to humanity and their tireless efforts to uplift their nation and the world. China's unwavering spirit and deep understanding of humanity elevate them to a position of admiration and respect. May China continue to shine bright, leading the way towards a better and more compassionate future for all. The journey through China's mega projects is one of awe and inspiration, a testament to human ingenuity, innovation, and the relentless pursuit of progress. Each of China's major projects showcases the remarkable feats that can be achieved when vision, technology, and sheer determination come together. If you found this video insightful, give it a thumbs up and share it with others. We would love to hear your thoughts and insights in the comment section below. Don't forget to like this video and subscribe to our channel to stay updated with more fascinating content. Thank you for watching, and we look forward to seeing you in the next video. Let's continue to explore, learn, and inspire together. Take care and goodbye.